paper number 13. And after this, we supposed to discuss paper-based revision 1 and 3. And its second one question, simple harmonic motion, we have to do. After the discussion of this, we supposed to start that. Okay, take paper number 13. Okay, paper number 13. First, we'll discuss part A. First part is question number 1. Right. Two particles A, B each mass M move in horizontal table along the okay, collide directly. Right. So these questions are first questions. Yes, 2023 or 2024 questions, applied maths paper questions. Huh? So they are very easy questions, right? So I put these questions purposely to give you the idea that if you put a little effort, you can really get rid of all issues as you thought in the exam. Exam questions are not that much difficult, right? So this way, the particles are available. A and B are moving like this. This is mass M. B also mass M. Here A, here B. It moves this way with 2u velocity, this way with u velocity. And after the impact, let us take, they begin to move with velocity v1. This is A, velocity v2. This is B, M and M, like this. Huh? Okay. Coefficient of restriction between A and B is C. Find the velocities of A and B after the collision. Yes, that means V1 and V2 we have to find. Show that if E equals 1/3, then A will come to rest after the collision, right? You know, basically the two principles we use, conservation of linear momentum and Newton's law of restitution. Okay, right. Conservation of linear momentum, we can apply this direction, right? Then here 2mu minus mu, here mv1 plus mv2. We can cancel down like this, right? v1 plus v2 is equal to u number 1. Second one is Newton's law of restitution. Okay, what is Newton's law of restitution? Relative velocity before impact, or E times velocity of approaching, right? E times velocity of approaching, no? So velocity of approaching means before, right? Velocity of approaching is what? 2u, no? 3eu then. 3eu. Velocity of separation, v2 minus v1. They separate, no? Yes, v2 minus v1. Right. Here, this is number 2. Okay, right. Okay, now you get 5 marks for the first one. This one also 5 marks. Okay, by adding 1 and 2, we can write. By adding 1 and 2, we get the value of V2. V2 comes as u by 2, 1 plus 3e. For this, you get another 5 marks. By 1 minus 2, we get V1. I am not going to show you the steps in simplifying this. You can very easily understand that. So for this also 5 marks. Then Here we get 20 marks. The last 5 marks is coming for the next answer. Show that if E equals 1/3, then A will come to rest after the collision. So if E equals 1/3, what happens is here, right? V1 U by 2, 1 minus 1/3 mean really this is 0. Then V1 0. V1 0 mean what? V1 0 mean the A comes to rest, right? Therefore A comes to rest. A comes to rest after impact for this 5 marks. Right now, this is how we take the first answer. Hurry up. Right. Sometimes you might have obtained this answer when you were writing this, even though write down this. Why? That gives another practice, extra practice, and giving more confidence, right? So that's good. Don't skip this, right? Okay. Second question. Particle is projected from point O, point A, at distance simple A above a horizontal flow at an angle theta to the horizontal with initial velocity this. It just clears a vertical wall of height this situated at the horizontal distance 3A from A. See the figure, show that theta equals this, right? This way we have the diagram. Right. This angle is theta. This height is A. This is 3A. Given here A, this is B. This height is 9A over 4. Right. Now we apply for AB motion, S equals ut. When the particle moves on this path from A to B, it moves right toward 3A. Here, upwards, this height from here to here. It is 9A by 4 minus A. Right, okay. S is this 3A. U means U cos theta times T. Then thereby you can find T. T equals 3A over U cos theta. You get 5 marks for this. Now for the same motion AB, we apply S equals ut plus half h squared. For the same motion, right? We apply S equals ut plus half at squared. Okay, now it is now 9A by 4. From this, we have to subtract this A. 9A by 4 minus A means 5A by 4. No? Right, this height, no? Once the particle moves from here to here, from this level, it rises to this level. That means its vertical displacement is this. It is this 9A by 4 minus A by A, no? 9A by 4 minus A is 5A by 4. No? Yes. This is 5A by 4. U means vertical component U sine theta. Okay. And for this T substitute here, 3A over U cos theta minus half G T squared. T squared is 3A over U cos theta perfect squared. Right. For this step given, actually application of this equation of motion upwards correctly 5 marks. And substitution for the T, there we found another 5 marks. Then 10 marks come in as 5 plus 5, right? 5 plus 5. Okay. Really, now we can simplify this. U and U, you can cancel down. A and 1A here, you can cancel down, right? So Uh, right. I can write. I'll keep this a. We'll cancel down that later. That otherwise it is confusing. Here, 5a by 4, 3a, right? Tan theta, and g by 2, 9a squared upon u squared. Here we have 1 over cos squared theta. 1 over cos squared theta means sec squared theta. Sec squared theta means 1 plus tan squared theta. 1 plus tan squared theta. Now 1a will cancel down this way. Okay. And also you are given this u value. U given, yes, right. Here now we have 5 by 4, 3, tan theta, 9 GA by 2, 9GA by 2. Here u squared. U squared mean 9 GA by 2. Because our u value given in the question, right? 1 plus tan squared theta. 1 plus tan squared theta. Okay. So then here the cancellation can be done this way. This 9GA by 2, this we can cancel down completely with this. So then you can see there we get a quadratic equation in tan theta. Quadratic equation in tan theta we get. So once I bring all the terms to left hand side, you will get this quadratic equation in tan theta, right? I am not going to show that step. You must do this again. So here you get another 5 marks. So once you take all these terms to left hand side, we get the quadratic equation this way. 4 tan squared theta minus 12 tan theta plus 9 equals 0, right? This is really perfect square root of 2 tan theta minus 3. Okay. So once you take all the terms to left hand side, we get this. This is nothing but 2 tan theta minus 3 perfect square equals 0. This left hand side, no? Yes. Then thereby you can subject theta, tan theta 3 by 2. Theta is tan inverse 3 by 2. Yes. Therefore, theta tan inverse 3 by 2. For the last 5 marks, we get for this final answer. Even though your answer is correct, try to do quickly before I take the answer here. Then you get another extra practice. Okay? Don't copy, right? Always familiar with copying. That practice you can't get rid of your body, your mind. Every time something, when you write, you need to copy. Don't copy, right? Try to get the answer yourself before I take the answer, right? So thereby, you can improve your working speed, right? And that you can apply when you write the paper today paper, right? Before I take the answer, try to get the answer from by you. Okay. So once I write the equation of motion, you know he is going to do this now. Then apply that before I take the answer. Thereby practice. Then first thing is the subject informations, the important things. You pick. Meantime, if you try to take the answer before me, you will form your speed. Okay. And meantime, you can make the confidence. The same experience in the evening you can apply for the today paper. That's how people we improve our skills. Otherwise, don't directly copy this down, right, to your book. Okay, next one, number 3. Yes. Yes, given next one, this way, 2A mass here. Okay, this poem weight is 4 mg. Here 2m weight is 2 mg. Here mg. This is P. This is R. This is Q. Here normal reaction is S. Right? Remember, people, in this case, marking all forces in the diagram, 5 marks given. Marking all accelerations, 5 marks given. So therefore, keeping something in your mind, don't go to write the equations. Okay. Here, all the forces you have to mark. Here, the tension T2. When you mark the tension T2, when the string connect external something, at that point, you must mark the tension in the string. So here, this chain connect to this body, this point on the string connect to this pulley. So therefore, here also we have to mark T2. Here also another end, another point on the string connecting to this T2. Here T2, same string, this is smooth, tension same. And from this end, T1, here T1, here T1, here T1. Okay, all the forces marked. Even here, this normal reaction you have to mark. For that, 5 marks given, no? All forces, 5 marks. So the other thing is acceleration. You know, once this move downward with certain acceleration, with the same acceleration, this moves right, this moves to up. Okay, same acceleration F. Okay, then that also you have to mark. F here, F here, F here. Okay, right. Then for that, another 5 marks for all accelerations, 5 marks. Okay, for all accelerations, 5 marks. Right. Now, what's asking there? Obtain equations sufficient to determine the acceleration of R. So, how many equations we must obtain to determine the acceleration of R? How many unknowns are there? F, T1, T2. Then 3 equations we must obtain. Understand? Then apply F equals ma for this one, this one, this one. For each equation correctly, if you have applied, 5 marks come in. That's how 25 marks distribute among the answers. Okay, right. Now apply F equals ma. Number 1, P upwards. What is that? T1 minus mg equals mf, right? Number 1, 5 marks. Second one for Q. We'll apply right word Q. Q is this, huh? T2 minus T1. T2 minus T1 equals 2mf. Number 2, another 5 marks. Third one, R downward. 4mg minus T2. 4mg minus T2, 4mf. 3. All right, this also 5 marks. See here, past paper questions, huh? Past paper questions. They are not really difficult, right? Basic things, huh? Right. Okay, that's how we take that. Okay, question number 4, work power energy question. Work power energy question. Now, those who need to evaluate yourself, best thing is today after discussion, right? Going home, now you know how to work out all the questions, everything now you know. Then try to answer the whole paper within 2 hours. See, those who practice like that, definitely they will come to a certain level within very short time. Okay? Within 2 hours, try to answer all the paper. Possible. If impossible, still you are not in the correct path. Hmm? Okay, right. That is to say, suppose in advance, among the questions we do here, one or more questions will be usually as a practice, as a usual happening in the paper in every year. This not my boasting, right? Sometimes same question, no, very close to the question in the paper we have done in the class. That is not a miracle really. Why? When you do all types of questions, class past paper sums, definitely one of those questions must come to the paper. At least 90% of same question usually you can see in the AL paper which we have done. Okay, right. Okay, therefore, once you do this paper again within 2 hours, that memory will come into your brain that will be very useful at the exam. Right? Therefore, the people they need to get the good results, they have more opportunity, more avenues, more chance, more time. Right? So whether you use this is up to you and go to the good results. Okay, a van of mass 1,000 kg is traveling along a straight horizontal rod against a constant resistance of magnitude 800 newtons. Right? This is a van. Hmm? This is a van, right? Right. So, right. Okay. Mass 1,000 kg, right? 800 Newton. Find the power of the engine of the van when it's traveling with a constant speed of 50 meters per second. 50 meters per second, right? The resistance is 800 newtons. The velocity 50 meters per second. 50 meters per second, right? Okay. The tractive force I take as F. Okay. Right. Tractive force F given by what? H equals Fv. F is H upon V, isn't it? H upon V. H is the power. I assume H has the power. Okay. H over what? 50. H is the power. Okay. You know, when it is moving at the maximum velocity, we are given, no? Constant speed 50. The speed is constant there. So therefore, at the constant speed, you know what? Tractive force is equal to total resistance. Hmm? Yes. So therefore, first equation you can write 800 is equal to H over 50. Then H comes as here 4 and 40 into 10 to the power 3, right? H is 40 kilowatts. Okay. Taking this 5 marks given and taking this another 5 marks given. Another 5 marks given. Huh? Right. So what is asking next? Now the van travels another straight horizontal rod against a resistance 800 plus 4V newtons, where V is the speed of the van. Okay, right. Second occasion, it moves this way. Still the path is horizontal. Yes. Find the acceleration of the van at the instant when the speed is 20, right? Speed is 20 meters per second. In this case, you are asked to take the resistance is 800 plus 4V. 800 plus 4 times V. V means what? At that moment, the velocity. At that moment, the velocity of the van is 20. Then that 20 we must put here. Therefore, it is 80, no? 20 into 4 is 80, no? This is the total resistance. Okay. And now the tractive force, right? If, okay. Here, asking to take the same power at the same power. But the same power means 40 kilowatt. Then we know power 40 kilowatt. At this moment, the velocity is 20. The tractive force means power divided by velocity, right? Now, in this case, I am going to assume the acceleration of the van as simple A. Then we can apply F equals ma rightward. Okay? Apply F equals ma rightward. What do you get there? 40 into 10 to power 3 divided by 20 minus here 880 is equal to the mass is 1000, no? Mass is 1000, no? Right. 1000 into A, right? For these people, really finding this force, right? Another 5 marks given. And for the equation, apply F equals ma equation correctly, another 5 marks given. By simplifying this, you get A. A also come in as 1.12 meters per second squared. For this, the last 5 marks come in. I'm not going to show you the way of simplifying this. You can simplify that. Right. See the past paper sums, right? Past paper sums are too easy. Okay, right. Right. Question number next, circular motion. Circular motion. This way we are given. Right. Okay. The mass is m, weight is mg. Right. Okay. Right. And normal reaction R. Normal reaction R. Tension is T. This angle is 60, pi by 3. Pi by 3. Yes. And people, this is moving, rotating with the constant angular velocity, root 2g over L. Root 2g over L. Same vertical angle is pi by 3. Same vertical angle means this angle, right? Pi by 3. Right. This tension is T. So if I draw vertical line like this angle should also be equal to what? This pi by 3. This is pi by 3. Okay. What is asking? The tension of the string. when tension is the string. If you remember, for the diagram, 5 marks given, na? 5 marks coming. So to get the 5 marks for this diagram, all the forces you have to mark. See here, you can get a nice hint there. In this diagram, right, no forces have been marked in the diagram. That is a hint. You might get 5 marks for labeling forces correctly. Understand? So therefore, some people, they do how? Just here and there mark and apply equations and take the answer. Then remember, for the diagram, that 5 marks you won't get. See here, no force in the diagram mark. They expect your knowledge here, how the forces act. Sometimes you might get the answer correctly. Doing mentally this, assuming the tension T here like this, and mentally you can do no. But people don't do mentally. Why? Then the 5 marks for the diagram you won't get. Okay? So therefore, they are the way of losing the mark without knowing you. So then you might calculate after coming home. You are the first examiner, no? The one who marked your papers. Then you put marks. Then according to marks, you must get 80. But you get 65. What has happened? You don't know the mistakes we have done. So then apply three corrections, the same thing. Then sometimes you might blame to what? The parents of the one who marked. But you don't know the errors you made. Understand? So therefore, uh, when you draw especially a diagram in applied maths, make sure to mark all the forces, all important thing, because for the diagram you get full marks if you have complete mark everything. I have seen in some markings, if at least one mistake is there when you mark the forces, deduct 5 marks. Okay. 2 mistakes, don't give marks for the diagram. So therefore, it's very important to mark the forces. Okay. Right? So then you might ask, what if this T here? That T, that is not important because we do everything for this particle, no? So though you mark other in the T also, doesn't matter. Okay. Here for the diagram, 5 marks. Okay. Now, what are the equations usually we can write when this is moving horizontal circle? When this is moving horizontal circle, particle doesn't move up. So therefore, it is in equilibrium vertically. So therefore, upward forces equal to downward forces, right? Then you can first run for vertical equilibrium. For the vertical equilibrium, what are the forces? T cos 60 r sin 60, no? T cos 60 r sin 60. T cos pi by 3, T cos pi by 3 r T cos pi by 3 r sin 60. R sin 60 or r cos 30 also correct, no? R cos pi by 6 because other angle is 30, no? This is equal to mg, number 1, 5 marks. Now, secondly, we apply F equals ma towards center. Okay? Right. The length of the string is L. This is L. This length is L. Right. So this is pi by 3 means, what is this radius? This radius going to be what? Radius going to be what, people? This is L, pi by 3. Opposite side only we need L sine pi by 3. Okay. Then tell me what are the centripetal forces? Towards center, T sine pi by 3 towards center. But this R will have a component outward. What is that? This is 30, no? T sine pi by 3 minus R what? Sine 30. Outward, no? Right. Okay. T sine pi by 3. T sine pi by 3. R sine pi by 6. They are the forces in the direction centripetal force towards center, right? Mass is m. Using the omega angular velocity, how to write the centripetal acceleration? R omega squared. R means radius. Radius is this. It is nothing but L sine pi by 3. L sine pi by 3. Omega squared means 2g upon L, right? This is second equation number 2, right? So then this also 5 marks, then 15 marks coming. Okay, people now, uh, by number 1, here, by number 1, right? By 1, find R. Then it comes like this, 2 over root 3 mg minus t divided by 2. Okay, right. And then for this we get 5 marks. Then altogether out of 25, 20 marks we have earned. Then this R we substitute in number 2. Now by 2. Now by 2. All right. I leave this as homework. What? This R answer we put where here. Okay. That also contain in T. The T is the only unknown. Then put in that R, this answer we are here. You can subject T. Then do this as homework. Right. So your answer for T should be 2 mg. Then finally the last 5 marks come in for this. So therefore you have a certain work to do as homework. Okay. Simplifying, take this answer. Okay. That simplification don't expect from me. Hmm? Okay. Next one. In the usual notation with respect to fixed origin, no, let the position vectors of 2 points A and B, 2i plus j and 3i minus 4j respectively. Let C be the point such that this. Find OC in terms of I and j and find the unit vector in the direction of OC in terms of I and j. Right. Number 6. X-axis I, y-axis j, here O. We have a point like this. A 2y plus j, B 3i minus 4j is B. Okay. Find OC in terms of I and j. Okay. Right. We are given one relation 2OA plus BC equals 2OC. This relation given in the question, right? C is a point such that it satisfies this vector equation, right? Find OC, right? OC means what? O is the origin, no? Then OC going to be what? Position vector of C. Understand? Okay. O is the origin, then OC going to be the position vector of C. So we know position vector of a point means what? The vector starting from origin and ending at that point. Okay. So then I take let OC vector be simple C. Okay. So you can substitute for this OA vector, that is this vector. And BC vector how to write? Second letter position vector minus first letter position vector. And this is C. Okay. You can directly use that. Okay. Right. Then we'll write that. 2OA, 2 times OA, 2y plus j, right? BC means what? Position vector of C minus position vector of B. It is 3i plus 3i minus 4j. Okay, right. And we get right hand side 2C. See here, marks come in. Substitution for this BC this way, 5 marks given. Okay, and for this equation, another 5 marks come in. Right. Okay, and for this also substitution 5 marks given. So this is the exact way of giving the marks in the marking scheme. This is 2023 part A questions. Right? See here, for the equation, 15 marks coming. Okay. So therefore, if somebody do this way mentally, see here, so anybody can put here 2OA means we multiply this by 2, 4I plus 2J. This he does mentally. That and this he simplify mentally and write the next answer. Then the step not appearing, so you lose marks. Understand? You lose marks. So you might say, no, it's we can do very easily mentally. No, no, no. That's true. But in the particular standard, they expect this. Understand? So therefore, if you don't follow the standard, you will defeat the game. So therefore, it's very important to show the steps. Don't keep anything in your mind. Convert that to letters in the booklet, answer script. Okay. Thereby, you get 15 marks come in by simplifying this. I am not going to show the simplification. You must do this. You get C I plus 6J. Okay. All right. So asking what? OC vector, no? So OC vector, then OC vector going to be I plus 6J. So for this, you get another 5 marks. Okay. Then 20 marks you earned. Next one asking what? Find the unit vector in the direction of OC vector in terms of INJ. So unit vector, how to write? How to write unit vector? Unit vector along a given direction of a vector, how to find? The given vector divided by its modulus. Okay. This is the given vector. In the direction of OC only we need no. Then unit vector, we can write what? Unit vector, we can write that vector OC, right? We divide by what? Its modulus. What is the modulus? I coefficient squared plus j coefficient squared root. Okay. 1 squared plus 6 squared root. Okay. This is how we take that. Then we get I plus 6j root 737. Okay. For this, we get another 5 marks. Okay. Right. Other questions difficult? No, not difficult really. Then if you were unable to answer the question in the paper, what is the issue? What is the issue? Yeah, negligence number 1. Less practice number 2. Next one, you don't have a good determination, right? Yet to get good pass. Simply still you are considering. No, take seriously to your mind and answer one paper at your best. Thereafter, the turning point begins in the life. Okay. So your mind, your mentality, you only the one who can change your life. Remember, even though I do this much, even though I gave you the question before your examination, if you don't take that seriously to your mind and do, you won't get good results. So you are the one who can change your life. Remember, you are the one. You are the one. We can help you. Right. Next one, take number 7. Take number 7. Yes. Uniform rod AB of length 4A and weight W is kept with its end, right? Yes, against a smooth vertical wall. Here also, some forces are not marked, no, in the diagram. Then you must be cunning enough. We must get some marks for the marking of the forces there. Understand? So the reactions, 2 reaction is not given there, right? So then we have to mark that. Then definitely we must get marks for the diagram. Okay, right. We'll draw this one now. Is how it. Here the wall. Here the peg. Right. So here A, AB. Weight W1 is suspended here. Right. It's a uniform rod. Weight W. Right. Rod makes an angle pi by 4 with horizontal as shown in the figure. The rod is in equilibrium. Show that W1 equals W2. A uniform rod AB of length 4A and weight W is kept with its end A against a smooth vertical wall. This is a vertical wall, smooth one. So therefore, there should be a normal reaction to the end of the rod. It is perpendicular to what? The wall. Understood? This way. All right. So here are this angle therefore pi by 4. Pi by 4. And here normal reaction we have this way. Yes. Okay. This length is 2A because the 4A is the whole length. And for this point, we are given that is C, no? This is given as 3A by 2. Okay. As we expected, 5 marks for all forces. For all forces. And remember, meantime, it is given in the marking. If you have made one mistake, no mark. These 5 marks you won't get. One mistake means what, people? You have marked this is not R not test. That 5 marks you won't get. Huh? Write down that too. One mistake, right? One mistake, no marks. Remember. So therefore, it's very important what to mark the all forces. I always emphasize you when you draw a diagram, all the forces, all the accelerations, all the data, mark. Sometimes in the particular year, particular question, sometimes for the diagram you won't get marks. That's something else. But you have done your duty, right? You have the eligibility of getting the marks because you have done. Right. Okay. Now we'll write the equations. For the equilibrium, of the rod, we resolve the forces vertically. Right. Let's see what are the forces vertically here. When I draw a vertical line here, this is 45, no? Because this is 45, this is 45, this is 45, this is 45. S cos 45. S cos 45 cos pi by 4 equals W plus W1. First equation. 5 marks given for this. Right. By simplifying this, people, yes, not equation number 1, 5 marks given. By simplifying this, you can find S. Cos 45 is 1 over root 2, no? Then root 2 come in, S come in, root 2 times W plus W1. Right, S we found. Now we take moment around A. Moments come in how? S into 3A by 2. Okay, anti-clockwise moment. W give clockwise moments. Right. So there we get what? This weight W. Right, what's the moment there? From here to here, 2A. When I produce this line, what's this length? 2A cos 45, no? W into 2A cos pi by 4. And by the W1, what do we get? 4A cos pi by 4. People remember for this equation 10 marks given, now 10 marks given, not 5 marks, 10 marks given. Okay. So how many marks so far we get? 20, no, out of 25. Now people, can somebody tell me how to take the answer? I'm not going to take the answer. You must do this again, homework. How? This is answer we found here, put here. Okay. Then in this equation, you will have only W and W1. Simplify this. Then we get the answer W1 equals W. Right? Simplifying this, you can take the answer. For that, you get final 5 marks. Simplify this and take the answer. Right? Those who complete this and completely finish this within 2 hours, they will finally win the game. So therefore, don't give up this, do them as homework. It's a good chance. Now, 80% of the paper, now you can very easily manage. Another 20 more, you have to manage. We have enough time. Once you get this opportunity and advantage, I think very easily you can, without any stress, you can go to the exam. Okay, right. We'll go to the next one, number 8. Number 8 also, in the diagram, marks is not marked, the forces not marked. That means they're supposed to give 5 marks for what? Whole diagram with the forces. Okay, right? We'll come to that, number 8. Particle P of mass 2m is on a rough horizontal table. One interval at string this way, no? Right. The section of the string from P to the pulley 5/6. Right. Okay. So this is the coefficient of friction mu between. Yes. Okay. Draw diagram there. This is Q, mass simple m, weight mg. Here 2 mg. Normal reaction is R. Right. Here the tension T acts. Okay. This angle is 30 given. Now, this particle P, because of this T has horizontal component, try to move rightward, then the friction come in this direction. Okay. I'll take the frictional force as F. Yes, here also for all forces, the diagram with all forces 5 marks. 5 marks. So what are the equations now we can write? For the equilibrium of P, we can write vertically forces, horizontally, and for the equilibrium of Q, vertically. Understand? 3 equations we can take. Okay? Right. For the equilibrium of P. Right. Here, T sine 5/6 plus R equals to mg. Right. For this 5 marks, right? Simplifying this, sine 30 is half, no? T/2 plus R equals to mg. Number 1. Right. This one horizontally for the equilibrium of this P again. T cos pi/6 equal to F. T cos pi/6 equal to F. For this also 5 marks. So by that you can subject if substitute for cos 30 root 3 by 2. Root 3 t by 2 is the second equation. Now for Q for the vertical equilibrium, T equals mg. T equals mg. T equals mg. Right? For this also 5 marks. Then 20 marks you earned. Now, you know, for the equilibrium of this P without slipping, what is the condition required? Uh, for the equilibrium without slipping, mu greater than or equal to frictional force divided by normal reaction. Right. So, we can write mu greater than or equal to F upon R. So, you might ask there, why don't you put here modulus? Though you put modulus in this case, never mind. But it's well obvious fact that F is obviously positive. No, here T can this T be negative? T is a tension. No, tension never be negative in this case. T is positive, therefore positive. R also by the equation there you can see R should also be positive because there should be a certain contact with this plane in order to occur what friction. No, so then R positive. So therefore, though you don't put here modulus sign, in this case, part A especially, never mind, we can take the answer, right? Yes. So then substitute this uh, if value you found, right? And R, yes, you can substitute there. You get the answer here. If value root 3 t by 2 we know. T you can find there really. Okay. Yes. T equals mg. Correct, no? Put this mg where here. That mg here. Subject R. Then put here. You get the answer. Yes. By this, you get the answer mu greater than or equal to 1 over root 3. I'm not going to show how to find f and r and put in here and simplify. That you can do. You know. Right. So this is the questions, right? Another 2 more questions available. Those 2 questions came from what? They came from stat and probability. Right? So stat and probability. 9th one is the probability. 10th one is the stat. So they are, now you can see out of whole syllabus except 2 questions in the part A, you can do the rest. Okay. So we soon start this probability also. I first finish what the integration, thereafter probability, thereafter center of gravity part. Right. Okay. Part B. Failure to, sorry, VT graph. Right. VT graph. Right. There are 2 tracks like this. Here, the distance between this P and Q is 1750 meters. Right. Okay, don't talk, start. Start with me. Before me, try to do the question. Though you have done question in the paper, never mind. Don't be lazy. Once you do the same question twice, it is not a disadvantage. Huh? That will be useful. Right. Because you know that, as I told before, in 2021, Kurunagari district, second English medium student came from our class. After receiving the results, he came to me and said he has done from 20 to 20, 2005, 15 papers 4 times. All 15 papers 4 times before the exam. He is told furthermore, once I do the third time the papers again, all the answers and steps are remember, very clearly remember. So therefore, some questions, of course, I mentally did. As a result of that, district second. Sometimes in physics or chemistry, a certain mistake he has done. Otherwise, he would be district one first. He has done fourth time the all papers from 20 to 2005. Uh, Third time, once he does the papers, he said every answers are remember, the steps are remember, so very lazy. But I did anyhow fourth time also. Then at the paper, I think he has done within 2 hours all the questions. Practice is only thing, people. Practice is only thing. So therefore, our people, they think, what, oh, I did this question in the paper. So then I am not going to, I am a great person. No, do, right? Do this. Hmm? Right. Okay, this is, right. Train A is starting, all right, here A is starting from P, no? Here. Train A is starting from P. Travels along the track R1 with uniform acceleration 10 meters per second squared, 40 seconds, and then maintains the speed it gains at t equals t seconds for 30 seconds. It then decelerates uniformly for t seconds and comes to rest at the station Q. Yes. Sketch the velocity time graph for the motion of the train A from P to Q. Okay, right. Right. So then, since you have read this question clearly, I think a story is in your mind. So then I directly draw the diagram for the VT graph. Okay. The train A moves, right, with uniform acceleration 10 meters per second squared over a time t. This time is t seconds, capital T seconds. Okay. Then at that moment, I assume the velocity it gains v, and then it moves with the velocity v, right? Another 30 seconds in the question given like that. Huh? Another 30 seconds. Very simple questions compared to the questions last that year we did in the class under revision and theory. This question is very simple question. Okay. Okay. Thereafter, within another capital T seconds, that comes rest. I take this point C, here B, here A, here O. This angle is theta, tan theta 10. Tan theta is acceleration, no, 10. Okay. So the marks given like this. For this part of the VT graph, 5 marks. For this, 5. For this, 5. Hmm? Right. Accelerated motion, 5 marks. Uniform velocity motion, 5 marks. Here, 5 marks. Let's ask in there. And show that the total time taken for the journey is 40 seconds. That means if you can find this t, Okay, right. Right. Here we can write tan theta. Tan theta equals V over T. Substitute for tan theta 10. 10 equals V over T. Then we can write V equals 10T. V equals 10T. You get 5 marks for this. 5 marks for this. Huh? Right. Okay. So next one is OABC area is what equal to PQ length. No? OABC area is equal to PQ length. Right. Write down OABC area. It is the PQ length 1750 meters. Okay, what is this? This is a trapezium. You know, area of a trapezium is what? Half sum of the parallel sides. Here 30 plus 2t, this side, and 30. 1750. Okay, right. People, here you get marks this way. For writing this area 5 marks, the right hand side equating that to this one and getting the equation 5 marks. Here, when you simplify this, right, I'm not going to show you the simplification steps. You get a quadratic equation this way. T squared plus 30t. When you simplify this, you get this 175 equals 0, right? Getting this quadratic equation 5 marks. So you must simplify this and take this as homework, right? Don't throw away the answers going home. Now we are okay. No, we must do, right? This quadratic equation 5 marks and factorize this. For the factorization of the 5 marks given, the factors are coming like this. T plus 35, first factor, t minus 5, the second factor. For the factorization, another 5 marks coming. And you know, t is a positive value, therefore t plus 35 first bracket is positive. Then this product to be 0, t should be 5 seconds. Okay, for this 5 marks. Then total time going to be what? Total time for the journey going to be t plus 30 plus t. Then 40 seconds, no? Right. 5 plus 30 plus 5. 40 seconds. For this another 5 marks. For this another 5 marks. Right. Right. Next one. Another train B traveling along the track R2 in the direction PQ at a constant speed 40 meters per second. Right. Okay. So another train B moving in the track R2 with constant speed 40 meters per second. 40 meters per second. Understood? Hmm? Hmm? Sometimes you might get certain understanding issue here. That issue is not because of me. You haven't done questions. That simplifications, everything you must improve yourself. Simplify this and take. Okay. Right. Those who do like that only people, they can come to a good level. Otherwise, no point of wasting time and money. Remember. Okay. Now, asking relative velocity, in the sense, VT graph of this A relative to B, no? A relative to B. We need VT graph of A relative to B. Sketch the velocity time graph for the motion of the train A relative to the train B. VT graph of A relative to B. Okay, I'll first explain this. Remember, people, this relative graph at the moment can remember the time we did this VT graph. That occasion you understood the VT graph also with many difficulties and issues. That occasion we confined our discussion only for the VT graph. Now think that moment if I try to do this way, relative, that means VT graph of A relative to B, of course. Today at least 20 students in the class are available. No one is at the moment. So therefore that says people in some lessons, once we do that lesson, that moment, because of your knowledge level, sometimes this type of things we can't do. This is the time after finishing what relative acceleration, relative velocity lessons, only this type of questions we can do. That's why usually I say once you do the past paper exams at the very beginning, you can do nearly 65-70% at the very beginning. By the end of the syllabus only, you can do 100%. So one example is this now. Now this kind of questions usually then we have discussed where? Like this a paper class. Like this a paper class. Understand? So the class is what? A different level. Right? So once you do the questions like this, you automatically come to a good confidence and good feeling coming. No, now we are okay, little bit coming out from our difficulties. So that feeling you must give to your mind. Then only motivation coming. Then only you will get feeling to do more sums. Confidence creating. That's very important, people. Okay, let's see how to do this. Now, people, whenever, now this is A, this is the A, right? Train A is this motion. Train A motion is this. Train B moving with constant velocity, right? Now, this is how you have to plan. First, this T is 5, no? Listen to me first, people. When we draw velocity time graph of A relative to B, right? When we draw VT graph of A relative to B, you know, in a velocity time graph, two important data available in the graph. What are the two important data? One is velocity, other one is the acceleration. So therefore, whenever you sketch VT graph of A relative to B, then we have to highly concentrate about these two things. What? First one is the velocity of A relative to B we have to consider before drawing the VT graph. Then second one is what? Acceleration of A relative to B also we have to consider. Understand? Second one is the acceleration. Acceleration of A relative to B we have to consider. These two facts we have to highly consider, otherwise your VT graph of A relative to B will be wrong. Okay? All right. So then, first one is this. Number one, at T equals 0. All right. I am going to write velocity of A relative to B. Tell me the principle of relative velocity. What is this? V A comma E plus V E comma B. Am I correct? Correct, no? So you don't know this one when we were studying what? Velocity time graph, no? Now only you know that. Right. At T equals 0, people. At T equals 0, what is the velocity of A? At T equals 0, velocity of A is 0. Understand? Yeah, this is 0. Okay. And this one, you know, by exchanging the letter, you can write this way, no? No? Yes, minus sign, exchange the letter. What is the result of B relative to Earth? 40 here. 40. Then put 40 here. Minus 40. Right. Then what can you say? Velocity of A relative to B at T equals 0? Minus 40. Then where should the VT graph of A relative to B start? Minus 40. Okay? That is a very good, important data. Okay. Next one. During the time, look at this, during the time. During the time, first 5 seconds. A moves with what? Certain acceleration. I told you, when you draw the VT graph of A relative to B, we have to pay our attention for the relative acceleration also. Now let us do, during the first 5 seconds, what is the acceleration of A relative to B? Understand? Okay. All right. Then first come to one by one. Write down one sentence like this. VT graph of A relative to B. Then write down this sentence. First one, put a star mark. Write down. In sketching, velocity time graph of A relative to B, A relative to B, we have to find velocity of A relative to B and acceleration of A relative to B. Okay, no? Right. Now then take the first data at t equals 0. This first data is this. Second data in first 5 seconds. In first 5 seconds. Okay. In first 5 seconds, now we are going to consider the acceleration. Acceleration of A relative to B. Tell me the principle of relative acceleration. Same as what? Principle of relative velocity. Only thing is, instead of velocity, we use what? Acceleration. Okay. A comma E plus A, what? E comma B. Okay. You know, no acceleration for B. It moves with constant velocity. So therefore, this is 0. A comma E. People, this is 0 now. This is 10. Right. Okay. Because the B is moving with constant velocity. B is moving with constant velocity. Acceleration is 0. Therefore, in the first 5 seconds, acceleration of A to B is 10. Right, this way we got. Right, no? Now, another moment we have. What people here? Second, third seconds. A moves with constant velocity. What is this constant velocity? V. What is this V? What is this V? T. Capital T we found to be 5. Then V is 10T. This is 50. Now, during this motion, that means second, third seconds of both, we have to again find what? Velocity of A relative to B and acceleration of A relative to B. Okay. Now, third one. Second, 30 seconds. Right. Second, third seconds. What is the acceleration velocity? Velocity of A relative to B. V A comma E plus V E comma B. Right. V A comma E. Second, third seconds. 50. Correct, no? 50. Put here. 50. Here you can interchange this order. Then we get minus. Minus. EB only, I can write as BE, putting minus sign. Now here we have what? VBE. VBE is 40. VBE is 40. 40. Put here 40. Here we get then 10. Right. 10. Correct, no? The second, third seconds, both frames A and B move with uniform velocities. Then no acceleration. Understand? No acceleration. Understand? Why? Both are moving with same, uniform velocities. No acceleration. Acceleration of A will be 0. Right. Okay. Third one, last 5 seconds. last 5 seconds. Okay? Last 5 seconds. People, can you see here? Right? Can you see here in the diagram here? This is 5, no? We can calculated. This height is 10. Then this triangle and this triangle, when you consider, this angle theta should be equal to this. Why? Reason? What is reason? Reason? Congruent. Okay. Then this tan theta gives what? Retardation of A. Last 5 seconds, it has a retardation. Understand? Okay? Right. Last 5 seconds, retardation. We need acceleration of A relative to B. Acceleration of A relative to Earth plus acceleration of Earth comma B. Okay? This is 0 because always we moving with uniform velocity. But here, acceleration of A relative to Earth. Last 5 seconds, really, A has a retardation. Retardation means what? Minus acceleration. Retardation is what? Minus acceleration. Am I correct? Last 5 seconds, A has retardation. Retardation is minus acceleration. Okay, right. A acceleration, A comma B should be minus 10. Right. Minus 10. Okay. After 40 seconds, see what happens. A has velocity 0. B is still moving with what? 40 meters per second. That also we have to find. Fourth one, right? Actually, though I write this all the things one by one, that is for your clear understanding, right? So these things, of course, without writing like this one you can just write like this. That's enough in the marking. That way it is shown. But I wrote that in detail, right? So that for the next question, another question like this, to apply these situations very clearly by understanding this way, detailed form. Okay, right. After 40 seconds, right. Okay. Last 5 seconds, retarding motion A has now, relative to B. After 40 seconds, tell me, velocity of A relative to B. Velocity of A relative to Earth, E, B. People tell me, after 40 seconds, what is the velocity of A? A has stopped. 0. 0. 0. This order we have to interchange. We get V, B comma E, 40. 40. Right. V comma V is minus 40. Right. Meters per second. Right. Who did this in the paper last time? Yes. Now sketch the graph. Now sketch the graph. Sketch the graph. So what should be this axis now? Velocity of axis of A relative to B. Understand? Velocity axis of A relative to B is the time axis. Right. T equals 0, minus 40. Where's minus 40? Here. Right. Minus 40. In the first 5 seconds, A has an acceleration of 10. First 5 seconds. Acceleration 10. What is velocity? Hmm? After first 5 seconds, what's velocity? End of the first 5 seconds? Yes, end of the first 5 seconds means what? Start of the second, third seconds. What is velocity? What is velocity? 10, no? 10, no? Hmm? No? After first 5 seconds, velocity of A is 10. 10, no? Sorry, 50. 50, other one 40, no? 50 minus 40, 10. Then this goes to where? 10, no? Here 10. This is the motion first 5 seconds. Okay. This is first 5 seconds. First 5 seconds, right. Second, third seconds, we know no acceleration, but velocity is 10. Understand? No acceleration. No acceleration means what? Horizontal line. Yes. Second, third seconds. Right? If you have your brothers or sisters who did the exam 2022, I can remember among in my one paper, in part A, this kind of question I put. Just to go through, I think you have your brothers among the papers available this question. Ask him to sketch the VT graph, this way given. Root motion, right? Okay, second, third seconds is 10. Finally, last 5 seconds, there's a retarding motion. End of the 5 second, velocity is what? Minus 40. Okay, then what should be that? Should come to here, this level. And 5 seconds is this much, no? All right, this is the VT graph. Right. For this, you get 5 marks. For this, you get 5 marks. For this, you get 5 marks. Right. Find in this 40, another 5 marks given. For both, this 10 and this 40, both 5 marks given. Okay. And people, this way, using this principle of relative acceleration and relative velocity, another 5 marks given. Another 5 marks given. No? So therefore, not sure. There's a chance of coming another very near future VT graph. There's a chance coming to draw this way, but relative motion graph. Okay. In the past papers, 2013, there was a relative motion question that I am going to put next day paper class under vertical motion. Relative velocity time graph asking to draw that we discuss next day. This type of question again may be asking, maybe near future. So therefore get ready for this. Okay, right. So another 1, 2 questions I'll put this way, considering relative motion. Now here people remember, in this question is a simple question because B is moving throughout uniform velocity. Suppose B also moving with acceleration or retardation. In that case, we get another extra calculation there. But during that particular period, you have to calculate not only the velocity, but acceleration also we have to calculate. That is a little bit complicated. We'll do that kind of question in a certain paper. Then if you get such question at the paper, you can easily manage that. Okay. Only thing is people, though I explain like this, you must practice this. Understand? When you do this alone only, you will find some questions at the moment you feel now. Understand? So therefore, it's worth to do the question yourself again. Then only you can speak to your backbone. Now you accept, now, okay, no. Now we have been taught like that, no, to use the relative velocity theory, relative acceleration theory, you accept like that. But once you do this only, people, you get some issues. That issues you can identify once you do the question alone. Okay, right. Right. So 75 marks come in. The second part going to be the relative velocity part. Uh, relative velocity part really available next question. Right. Go to next part. Who did this relative velocity? No. എനിക്കറിയാൻ Right. Who did the relative velocity? You did last week, Epson, no? Hmm. Right. The discussion, of course, really feeling those who wrote the paper at that moment last week. Understand? Okay. The people who wrote the paper in the class only, the discussion will get thoroughly to mind. Huh? This is to hear. Suppose you hear a certain story, here and there. Here and there you hear a certain story. But once you go through the summary, it's very interesting one. Very interesting one. So now you couldn't hear that well. Some places deleted though you couldn't hear well. Now, secondly, you have the chance of hearing the whole story. What happens now? Your attention is 100% and you entertain that very much. Like that here. So at the moment when you write the paper, you were unable to ask that. You couldn't find what the point to get the answer. Now you are looking this very grady nature. What is the method? Then once you pick that one people, forever that memory available in your mind. Okay, that is what people we say, what we study something. Right. Go to the next question. Question number 10, relative velocity. This is very simple question, right? Okay, that question is, a river d meters wide flows at uniform speed u meters per second in between two straight parallel banks. A swimmer p whose speed relative to water is root 2u, right? Start from a point A on one bank, seems to reach the point B on the other bank, directly opposite to A. Yes. This is the diagram. D meters. A. This is B. Here C. This is also D meters, right? The river flows with velocity u. Right. Right. Now the swimmer P is here. P is here. Right. People now, question says, now this swimmer P seems so that finally he can go to what? This B. Does it say he is pointing his body along this AB line? No. Then finally, and observing the earth, observes the swimmer P moving along this line. You know in the lesson as you learned, in order to move while the water flowing this way, in order to move along the line AB, definitely the swimmer must make his body making certain angle with this line, no? Then he moves this way, water will have this way, the two velocities will have resultant along this way, then this is a possibility. So that is how you must understand the question. Okay, right. Then this way marks come in. Velocity of water relative to earth. This way you are 5 marks given. Velocity of P relative to water. What is this? Velocity of P, stream of P relative to water. In the question given as root 2u. Question given as root 2u. For this also 5 marks. Tell me velocity of P relative to earth. Velocity of P relative to earth. We are given. In the question we are given, no? Starts from a point A on one bank and seems to reach the point B on the other bank, directly opposite to A. Right. Okay. He finally comes to what? Point B. That means an observer on the earth notices P is moving along this line. AB line. What direction? This no. Perpendicular bank. Okay. For this also 5 marks. Right. Now we can write. Now we can apply principle of relative acceleration, relative velocity. P, VPE, VPW, VWE. Right. XY, YZ, this is XZ. Okay. Now, XZ, we can write this way. XZ. XY means velocity of P, W na root 2u. That direction we don't know. Root 2u. Given by XY. We wrote that like this, no? XY, this is given by what? Root 2u. We wrote like this, no? Given by XY. Right. WE, this way, YZ. It is U. Okay. Now, no need to draw in this case what? Circle. We can just draw the triangle. XY is a triangle, no? XY is a triangle. Yes. XZ should be vertical down, no? This way. XZ. XZ. YZ. This way. Then Y should be here. For YZ to be downstream, Y should be here. XY is this now. Okay. Here 90. XY root 2u. This is U. YZ. For this, where is the triangle? People 10 marks given, no? 10 marks given. Now, XZ squared we can find by using the Pythagoras theorem. XZ squared. It is, here square this, 2u squared, subtract u squared. XZ going to be 2u squared is u squared is u, then no? U. Right. Okay, no? What is this XZ? Velocity of P relative to Earth. XZ. Therefore, finally, along this line, okay, that sigma P, here, look at this XY. What is XY? Velocity of P relative to water. It says what? XY direction says the body, the swimmer, what turns on the water surface to continue this motion. So what is XY here? This way. Look at this XY this way. That means this is U, no? Just now we found. This is U. This is U means what is this angle? 45. That means what? Swimmer should make what? An angle 45 with the edge of the river. This is how he turns his body. This is 45. Ah, turning the body like this, he moves like this. Okay. Ah. What is the velocity of swimmer P relative to Earth? U. Then with that velocity U, he must move what? This distance D. Then what the time? D over U. Am I correct? All right. Time is D over U. Time, the time. D over U. All right. For this, you get 5. Finding x is at 5, time is 5. Theta 45, yeah? Right. Theta 45 is. Right. Now, read the next part. Read the next part. Next part says something like this. A second swimmer, Q, whose speed relative to water is 2 root 2 u meters per second. Second swimmer, Q. Velocity of Q relative to water, 2 root 2 u meters per second. Starts from a point C further down the river D meters from B. Meaning here he starts Q. Q starting from this point C. Right? Now, at the moment, P starts from here, making his body this direction. Q starts from here. Yeah. And swims with the intention of meeting the swimmer P. With the intention of meeting the swimmer P. Right. Assuming that the swimmers P and Q start to swim at the same instant, show that the swimmer Q meets the swimmer P before the swimmer P reaches the point B. Nice. Right? People think like this. Once P begins from here, right? Q start here to catch P. Okay. Now I am going to consider the motion of Q relative to P. Motion of Q relative to P. Relative to P means what should we do? Whenever we discuss relative to P, what should we do? We have to stop P, no? We have to stop P. Since both P and Q start at the same time, once they start their motion, suppose we stop P. That means from that moment onwards, we supposed to discuss the motion of Q relative to P. That means we must stop P here. At that moment, Q begins from here. Now, in order to catch this P by this Q, in what path relative to P this Q should move? We have stopped P here. At that moment, Q is this. Then definitely, once we join C and that A, along that line, the Q should move relative to what? P. Am I correct? Yes or no? Yes. That means we stop P here itself at the very beginning, both are starting their motions, right? This way. Now, P is here. Then, while P is here, to catch P, Q must move along this line. You know, this is D, therefore this is 45. Now we can write record informations. Yes. What are the information then we can write? Yes. Velocity of Q relative to water 2 root 2u for these 5 marks given. Velocity of P relative to water. Velocity of P relative to water. Velocity of P relative to water, people. Here, velocity of P relative to water. It is given by PWXY, no? What is XY? This direction. So therefore, velocity of P relative to water this way, make in 45 here, that I have marked already. 45. This is 45. This is 45 with velocity. What people we calculated, that means given, no? Root 2u. Now tell me velocity of Q relative to P. Velocity of Q relative to P should be what? Along this, no? Along this, yes. Make it 45 like this. This set of information also you get marks. Hmm? For this 5, this is 5, this is 5. Okay? All right. Now we can go to principle of relative velocity. Velocity of Q relative to P. Velocity of Q relative to water. P, W, P. Let us take this as AB vector. This is BC vector. This is AC vector. Then AC vector should be pointing this way. We could have taken other different letters, right? So don't confuse with this ABC letter available in the diagram. Huh? This ABC we used independently of this ABC. Yeah? No relation between this ABC and that ABC. Yeah? Right. Here AC. Making this is 45. QW. QW given 2 root 2 U. This is given by AB. AB vector. BC. Right, people tell me what is BC? WP. Right? PW this way. But here we need what? WP. These letters interchange the order. Should go the other way. Huh? Here we need WP. PW this way. Then WP should be what? Opposite. Yes. This way. PC. This is 45. Right? It is root 2u. All right. Now we'll draw the versus triangle. Right. BC we can draw like this. Making 45, right? This is 45 with horizontal. 45. AC also 45 like this. This is also 45. Then obviously this should be 90. Here we have A. This is our right. AB this way. This is 2 root 2u, right? WBC root 2u. This is root 2u. Okay. AC is this. What is AC? Velocity of Q relative to P. Hmm? Yes or no? Hmm. Right. For this 10 marks, huh? Right. Since this is a right angle triangle, now you can write very easily AC. What is AC? Velocity of Q relative to P. That means what? P is resting at A. While P is resting at A, along this along this path, now Q is moving. Its velocity, his velocity only given by what? This AC length in the diagram. That we have to calculate now by using the Pythagoras theorem. Hmm? Right. Then AC squared we can write 2 root 2u perfect squared minus root 2u perfect squared. Then we get AC root 6u. 5 marks for this. Right? Now people, tell me, the velocity along this line now, Q moves with what velocity? Root 6u. Root 6u. Here P is resting. Now, what the time? What the time this Q takes to reach this point? What is this length? D squared plus D squared root 2D. No? Root 2D. Hmm? Root 2D. What the time? Time taken Q to catch P. Huh? Time taken Q to meet P. What's that? Root 2D is a distance. Time means distance divided by velocity. Root 6u for these 5 marks. Right. Now you can see earlier. Right. Root 2D. We can simplify this way. 1 over root 3 D over U. This is time. Hmm? Now I am going to compare this time with the time. What the time we earlier calculated P takes to reach what the point B? D over U. I am going to compare this time with D over U. What is the D over U? First tell me, when you compare this and this, which one is bigger? Which one is bigger? This and this, when you compare. This means this, after simplifying by root 2. Hmm? Of these two, which is bigger? This one is bigger, no? Here d over u, but here d over u divided by what? Root 3. This is bigger. What is this time? The time P takes to reach B. What is this time? The time Q takes to catch P. Since this is smaller, what can you say? Before P reaches B, Q catches what? P. Understand? That's what we need to prove. Then we can write, this is 5 marks. Then we can write, therefore, Q meets P before P reaches B. Hmm? Therefore, Q meets what? P before P reaches B. Right. This is how we complete that question. Okay. Right. We'll count to 5 minutes break. Next one, question number 11, related to acceleration question. Right. System released from rest from this position with the string taut. So that the particle P moves vertically downwards if m less than 2m. Describe the motions of each particle and the wedge if m equals to m. Right. First, draw the diagram there. Right, stop talking, people. Start to draw the question. Here, you should mark all the forces there. Weight mg, normal reaction is 90. This is this OMG, normal reaction R, capital Mg. Tension T mark like this. If the acceleration of this is capital F, this is also capital F. Let us take this expression is simple F related to this wedge, this angle pi by 4. Right. You get 10 marks for whole diagram with all forces. If not, you won't get 10 marks. Huh? Right? Okay. Now, some people, they mark only the forces which are important to take the equations only. No, 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 no. Some people, they mark only the forces which we need to take, which we need to write the equations. No, all the forces acting on the system, we must mark. Then only this 10 marks coming now. Right. Right. People mark in equal accelerations like this. Another 5 marks given. For equal accelerations. Mark in this way, equal accelerations. 5 marks. Okay, now you can write acceleration of particle Q related to Earth. We can write this way capital F, this way simple F. This is 45. Right. Now we can write, ask him to write yes, no. F equals MA, now we can put number 1 for P downward. P is this, Q is this, no? This is Q. P. Mg minus T. M capital F. Number 1, 5 marks. Second one for Q, this way. Mg sine 45. Mg sine 45. Right. M, right. F plus capital F cos 45, no? Here, number 2. For this 10 marks given, no? Third one, Q and wedge. Rightward. What is the external force? T. This T, T equals 4 M capital F. Simple M, the mass of Q, capital F, minus simple F cos 45. Sorry, capital F plus. Both come in this direction. 4mf. Right. This is third equation. Another 5 marks. And here 5 marks given for this 5 marks. Right? For this 5 marks given, this 5 marks given. For the equation, 5 marks. Huh? Equation also you get mark. If something is wrong, the 5 marks for the equation you won't get. Huh? For instance, if this is wrong, this 5 marks you won't get. This 5 marks you get, but this 5 marks you won't get because this 5 marks is coming for what? Correct equation. For the to get this 5 marks, everything should be correct. Once you get this 5 marks, this 2 marks automatically coming because equation becomes true if that first part become true. Right. Okay, people now. So I'm going to just write. Not going to show you the steps. You must do this as homework by adding 1 and 3. Right? 1 and 3 means this minus t, this plus t we can cancel down. We get something like this. Mg equals capital F 5 simple m plus capital M plus mf over root 2 for this 5 marks given. By number 2, this one, we can find simple F. By 2, simple F, we can write g minus capital F over root 2. Okay. Now, this simple F, we substitute where here. Okay. This simple F, this answer we substitute where here. Okay. For that substitution, 5 marks given. Right? For this substitution, 5 marks given. Okay. And now I am not going to show the simplification. You must do the simplification and take this answer. You will get F this way, capital F. 2 capital M minus simple M over 2 capital M plus 9 simple M times G. This is the capital F. Okay. Right now, show that the particle P moves vertically downwards if simple M less than 2M. Right. You can write if simple M less than 2M. Simple M less than 2 capital M. Bring this side. This gives us what? 2 capital M minus simple M greater than 0. Here. It means this numerator positive, denominator positive, G positive, capital F positive. It means what? This capital F positive. That means what? P moves downward. Correct, no? Then you can write. This means F positive, therefore P moves downwards. P moves downwards. Okay, right. Next one. If M equals to M, if simple M equals to capital M, simple M equals to capital M, simple M equals 2 capital M. That means what here? For the simple M also, we have to put 2 capital M. What is this? 2M minus 2 capital M. 0. F0. F0. Huh? F0. Acceleration of P. 0. Acceleration of P means acceleration of which? Acceleration of P and which? 0. What do you mean by this? Acceleration 0 means what? Acceleration 0 means either rest or moving with constant velocity. No? No? But you know, at the very beginning, this whole system was at rest. From the resting moment, acceleration 0 means and the wedge both at rest. Okay. Acceleration 0 doesn't mean always object is rest. No. Acceleration 0 means either object rest or object moves with uniform velocity. But at the very beginning, just before starting the motion, the system was at rest. It didn't have any velocity. From that moment onwards, acceleration 0 means the system rest. That means what? F0 means what? P and which both are at rest. Okay? F0. Right. They write down. What comes? See, after reaching here, you can write which and particle P are at rest. Which and particle P are at rest. Hmm? Which and particle P are at rest. Then what about this particle Q? If capital F0, simple F is what? G over root 2. Therefore, particle Q moves with the acceleration G over root 2. Write down that. Particle Q moves with the acceleration G over root 2. For that, 5 marks. For that, 5 marks. Right. This is the end of that question. Right. Take next one. Take next one. Fail to, circular motion. Final marks, 5 marks, explanation of what? That wedge and the particle at rest, Q moves with acceleration G over root 2. Why? Over there, capital F0 means simple F, G over root 2, no? That's why. Hmm? Right, that's why. Right, come next. Come next. Right. This diagram. Hurry up, hurry up, hurry up. Right. Here the section BCD smooth, right? AD. BCD is smooth. Huh? BCD section smooth, AB rough. Right. AB rough. Coefficient of friction inside AB is half. Q moves through the table to tube and collides and coalesces with the particle P. Find the velocity with which this combined particle R starts to move. So the speed V. Is it printed as U? Should be V, yeah? Show that the speed V of the particle R when OR turns to an angle theta with the downward vertical is given by this Rn. Okay. First one, here, I can write, this is Q, this particle Q, right? For, right? Vertical equilibrium of Q. Q moving this way horizontally, then R equals mg, R equals mg. R equals mg. R equals mg. 5 marks. We apply F equals mu R this way, not this way, right? F equals mu R. Mu given as half mg. Then frictional force is mg by 2. Five marks. Now F equals ma, we apply this way for Q. So you can find this velocity at B using two ways. What is when way? One first way, using the conservation of mechanical energy. Okay. Other one is equation of motion. I am going to find first the retardation in the section AB, retardation. How? Apply F equals ma. Force is minus, no? Leftward, no? mg by 2. Mass and acceleration. M and M you can cancel down. The acceleration is minus g by 2. For this 5 marks, this is 5 marks. Right. Now we can apply velocity of Q at B. Velocity of Q at B. Apply V squared equals U squared plus 2A is this way. V squared. Initial velocity squared is 5GA plus 2 times A. A means acceleration minus G by 2. S is the distance A. This and this we can cancel down. V squared come in how? 2G. V is 2GA. 2 root GA. For this answer, 5 marks. Then once the particle Q reaches here, it has the velocity is 2 root GA. Okay. Thereafter, BCD section is what? Smooth. Smooth. So therefore, no loss of energy thereafter, since that is smooth. What is asking next? Find the velocity with which the sorry. With which the this combined particle are starts to move. Yes. Okay. Now the last another sentence given this way. Write down this. Therefore, velocity of Q just before it collides with P. Therefore, velocity of Q just before it collides with P is root 2 root GA. For this another 5 marks given. Okay. Find the velocity with which this combined particle R starts to move. Right. Now, here this Q comes to the position C and make the collision. Now, we can draw that diagram too. This way. Right. Q comes here. And now Q and P make the collision. And the new object is R with mass 2m. This is R. Right. This velocity, suppose V. Right. Sometimes you might confuse with this velocity. I'll take it as V1 now. What velocity? Velocity of Q at B. Right. Now Q moves with V1 like this. Right. At the point B, Q has this velocity. Now it moves to C with that velocity. No loss of energy because it's smooth. Okay. So this then just before the collision, Q moves with velocity V1. Just after, the P and Q combine and make new object R. Mass is now 2m. Okay. Right. Correct. No combined particle R. Combined particle means they coalesce each other. Coalesce means particle is now 2m. Right. Apply what? Conservation of linear momentum, CLM. This way. What do you get? 2mv? V equals m. V1 means that velocity 2 root G A. M 2 2. You can cancel down. V is root G A. For this 5 marks. Right. Now combined particle come to here. Combined particle means mass 2m. Mass 2m. Here, normal reaction. Suppose this. At this moment, suppose velocity around the tangent u. Here 90. Weight is 2 mg. This angle theta. Here, the combined particle had the velocity v. That v velocity given by this. Right. Now, what is asking there? So that the speed v of the particle, no? V of the particle r, yes. We'll take this as v dash then now. Now the v is given there, no? This is the v. Here v. Yes. Right. Now we had apply conservation of mechanical energy. For that we need the potential energy 0 level. I take this as a potential energy 0 level. Then initially here the combined particle r begins to move with velocity what? This v dash. Then write the energy there. And here combined particle has both kinetic and potential and thereby subject this v. Correct, no? Right. Write down now. Applying Conservation of mechanical energy. Right. Half here when R combined object begins from the point C, its velocity just now we calculated as rho GA. But the mass of the R is 2m. Kinetic energy only it has half mass velocity squared GA. That only. Potential energy 0. Right. When it comes here, what is that? Half mass V squared. And now this height we need. What is height? Mass is 2mg. This height we need to find. All height is a, this part is a cos theta. A minus a cos theta. Right, people marks given this way. For this kinetic energy, 5 marks given. Right in this potential energy, 5 marks given. And for the equation, 5 marks given. And when you simplify, I'm not going to show you the simplification steps. We can take V squared. V squared come in by this answer. GA 2 cos theta minus 1. For that, 5 marks. 5 marks, huh? Okay, now next one read. And find the reaction on the particle R from the tube. From the tube. That means we need to find S. At the instant when it comes to instantaneous rest inside the tube. Instantaneous rest means what, people? For a 0 seconds, for a 0 seconds of time, velocity becomes 0. Huh? Not permanent rest. Permanent rest means what? That comes rest permanently. Instantaneous rest means now when you project a particle vertically upwards under gravity, once it moves upwards, you know velocity decreases, and one occasion its velocity is 0. For that moment only it is resting at there. Next moment that begins to move. Then at the highest point only the velocity is 0. That moment only we say what? Instantaneous rest means that. Okay, right. Okay, now we know first of all we'll see when the particle comes to rest V0. Put V0 here and find theta. That moment we have to find S. Okay, right. You can write when R comes to rest, R comes to rest V0. V0 mean, people, 2 cos theta minus 1 equals 0, cos theta half, theta 60. For these 5 marks, for these 5 marks. That moment asking is, now what we do? Apply F equals ma towards center, no, at that moment. At that moment means what? V0 and theta 60. Now apply F equals ma towards center. What are the centripetal force? R. This is theta, no? But theta we just now knew as 60. S minus 2 mg cos 60. No? S minus 2 mg cos 60 is the centripetal force. Mass equals mass into centripetal acceleration. V squared over radius. But at that moment, velocity 0. Then V squared 0 means acceleration 0. Right? This is 0. Then we get S equals mg. Yes. Then for the application of F equals ma towards into 5 marks, find in S 5 marks. Right. Next one, we have simple harmonic motion. I'll take simple harmonic motion question at last. Okay. Last week also we have simple harmonic motion to discuss. Both questions I suppose discussed together. Then go to question number 14. Go to question number 14, the last question. Right. Take question number 14. You are given number 14, the pentagon ABCDE, ABCDE, shown in the figure, is symmetric about y-axis. The vertex A and C lie on the x-axis, and the vertex B lies on the y-axis. Given AC for ADE, AEG 120 and OAB 60 years. That is a real number. It is given that the system of forces is equivalent to a single force, capital R, acting through B. Find the value of lambda. Find the value of lambda. Hmm? Yes, you are given this is 60, right? This is 120. About y-axis symmetry, therefore this also 60 due to symmetry. Here 90. This is 30. This is also 30. This is given as 120. Okay. Due to symmetry, this is also 120. Due to symmetry, these two must be equal. Due to symmetry, yeah? 120, 120, 240. What should be the sum of these four angles? 360. No? 120, 120, 240, another 120 should be there. Then each should be here, since these two are equal, 60. Huh? Due to symmetry, right? The word symmetry is very important to find the geometry in this case. Due to symmetry, what? This and this must be equal. 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 Okay? And therefore, this is 60. This is 60. This 260 means what? 60, 120, 180 means this line and this line parallel. That means this line also parallel to x-axis. Understood? Right. Hmm. Here A, B, this is y-axis. This point is C, this is the x-axis. D, N, this is C. Right. Here 2P, 4P. Here 4P. Here lambda P. We get this length is 2A. This is 2A. Right. AC 4A. Yes. Then what is this length? DE. Hmm? Should be? Yes. Okay. Okay. Now this line should be 2A. This is A. This is A because symmetry, right? Okay. Now what is given there? The resultant force is given that this system force of forces equivalent to a single force R acting through O R. That means the resultant force of these forces acts through point O. Okay. Then when you take moment around O, what can you say? We have a theorem, no? What? Taking moment around any point of the forces is equal to what? Around the same point, moment of the resultant. That way we have a theorem. Okay. Algebraic sum of the moments of the forces around the point is equal to what? About the same point, moment of their resultant. Okay. When you take moment around O, since now we can take moment around O of these forces, that should be equal to what? Resultant force. The moment of resultant force around O. But it is 0 because resultant passes through O. Thereby you can find lambda. Hmm? Right. Take that now. Write down. Moment around O, say clockwise 0. Right. 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 Around O, when you take moment, what do you get? You can take moment around O like this. Here. This one, you can resolve down and horizontal. Horizontal component passes through point O, no moment. 4p we can resolve this way, 4p cos 60. Other one is 4p sin 60. After resolving that two forces, take resultant downward as lambda p sin 60 minus 4p cos 60. Okay, am I correct? Or else we can take moment like this too. I think the method by resolving forces 4p and lambda p here, when you take moment much easier. Okay, resolve this 4p, 4p cos 60 passing through O no moment. Lambda p cos 60 passing through O no moment. Now vertical components 4p sin 60 upwards, lambda p sin 60 downward. That two component resolve downward, lambda p sin 60 minus 4p sin 60. Clockwise moment gives what distance? 2a. 2a, right. Lambda p sin 60 minus 4p sin 60 into 2a. Okay. Is it clear there? Resolve here too. 2p cos 60 passing through the point on no moment. 4p cos 60 also no moment. Then around O to take the clockwise moment, resolve vertically. 2p sin 60 minus what? 4p sin 60 into what? 2a. 4 2p sin 60 minus 4p sin 60 into 2a should be equal to 0. For this moment equation, 10 marks. Right. Simplify this. 2a you can remove. Sin 60 also you can remove. Lambda p minus 4p, 2p minus 4p, 0. Lambda 6 come in, 5 marks. Lambda 6. Okay. So what is asked next? Find the value of lambda and magnitude and direction of r. Magnitude and direction of r. Resolving forces this way, upwards, y. 2p sin 60, 4p sin 60, right? 2p sin 60, 4p sin 60, 6p sin 60, right? And here, minus 4p sin 60. And here what? Lambda is 6, no? Minus 6p sin 60. These two you can cancel down. Then we get, this is minus, no? Downward direction, y. Sin 6 to root 3 by 2. Cancel down here. 2 root 3p. 2 root 3p. Right. 5 marks. Resolve horizontally. Resolve horizontally. We get x. What do you get there? 4p cos 60. Rightward is 4p cos 60. Leftward. They cancel off. 2p cos 60 and lambda p cos 60. Right? 2p cos 60. Rightward, but lambda 6, that's compound leftward. 6p cos 60. Then what do you get? Leftward we get 4p cos 50 means 2p. For this also 5 marks. That is leftward now. Now we can write the resultant force. Magnitude and direction of resultant. 2p here, this way 2 root 3p. Suppose this is r. Let this angle be theta. What is r? R square root of 2p squared plus this. When simplify this, we get r 4p. 5 marks. Tan theta equals y by x 2 root 3 p divided by 2p. Here 60. Here 60. 5 marks. Okay. Okay, no? Right. Now what is asking next? Read the next part. Now a force of magnitude 2p acting along DE. Ah, right. 2p force is put along DE. Right. Now listen to me. All right. Ah. ළමයි දෙන්න අහගන්න. හරි. දැන් ළමයි කියන්නේ මොකක්ද දන්නවද? නෑනේ. ආ. මේකේ ළමයි DE වලින් 2p force එකක් දානවා. After that a couple is put. හරි. Now think like this. We know when we have a single force like this in a system, when we add a couple to this, what is the result? The single force moves from here to another. Does the direction change? No. Does the size change? No. Only thing is, its point of action due to the application of this couple, what displaces. Right. Now, people, here in this case, we are given, right? So far, this is 23 question. So far, given this way system of forces, only a couple applied in the previous questions of these examinations. This year, a couple and force both applied. Then this is how we analyze the situation. We are given a couple is applied, forward 3PA acting in the counterclockwise sense. Okay. Now this is how we people summarize the situation. Right. Now I roughly draw the diagram here like this. Right. This is the given pentagon. No. Right. This is a given pentagon. This way. This is a pentagon now. Right. The existing resultant now acting here are, right? Its size is 4p, it is 60. Right. Both know. Now suppose this 2p force applied this way. All right. Now people, now this 2p and this r. Understand? This 2p and r. For the two forces, we can find resultant force. Okay? They meet here, no? They meet here. They meet here. Then the resultant force, right, of this 2p and this r will be passing like this direction. All right. Suppose this is S. What is this S? Resultant of this earlier resultant and applied, newly applied 2p force. Now we are given what, people? Now we are given what? To this, with the force 2p, couple is added, no? This way. What is the size of that? 4 root 3pa. Now what happens? Now for this r and this 2p, we found single result force S. This S will be displaced by what? This couple. That's what happens. Am I correct? Okay. This is how we summarize when not only a couple, but force also newly added to the system. Newly added force plus the previous resultant. For that too, we find the resultant. That is this S. Now this single force S is what? Displaces by what? This couple now. Understand? That's how we have to manage the system. Okay. Now I'll take this situation like this. Okay. I can take it this way. What is asking there? Find the magnitude and the direction and the equation of the line of action of the single force to which the new system produces. Right. Okay. Now I'm going to find the new resultant. Right. New resultant force. New resultant, fine. New result means what? We can resolve this way. We can resolve this way. What do you get? X. This 2p plus early resultant force when you resolve this way. What do you get? It's horizontal component. What was that? Capital X, 2p. Okay. This 2p and this r for both, we have to find result, no? Then we have to resolve this force and this force leftward. This r has leftward component, 2p. This 2p, 4p. This way 4p. Okay? Resolve downward. Let us take y. This has no downward component. This has what? Early found y. What is y? 2 root 3p. Yes, 2 root 3p. Okay. Now we can find the new resultant S. New resultant S we can find. Let us take this angle as alpha. This is 4p. This is 2 root 3p. All right. Now what do we get? S. S is going to be 4p perfect squared, 2 root 3p perfect squared. When you simplify this, we get S. S as what? 2 root 7p, 5 marks. And tan alpha we can find. Tan alpha. It is y. Y means 2 root 3p. X 4p. Alpha. Tan inverse. What do you get? Root 3 by 2. For this, another 5 marks. Right now. Customer. Paravilla. Okay. Because now this S only displaces by what? By the application of this counterclockwise moment. Understood? Yes. Right. Now I am going to take this way now. Sanju. Sanju. Hari Suratal nih. Right. Okay. Right, people now I think like this. All right, like this, this way, right? Now, the I take like this, people, the single resultant is I am not going to mark in this diagram. In this diagram, I supposed to mark this way. Look at this R. This is point O. That 2P. This way, right? These two together give S. Therefore, in this diagram, really this S available. This is available. Okay. Now to this we apply this way anticlockwise 4 root 3a, 4 root 3pa moment. But we know because of the application of this moment, right, couple, that said single force is what displaces. Therefore, these two together give what? This way single force. What is that single force? Is this way, right? Now we found the magnitude, direction of S. We need to find what? Line of action. Okay. Now tell me, these two forces plus the couple will give what? This single force. Understand? Therefore, around this point O, the total moment of this should be equal to what? The moment of the single force, no? I will take moment around O. Understand? will take moment around O. All right, take moment around O. Hmm? Yes. What do you get? Ah, what do you get there? Okay, we take moment around O. Shall we take anticlockwise? This way. What do you get? Couple forward 3 PA. No, that is given. Never mind. Forward 3 PA. Right. This should give what? Clockwise. Minus 2P. Tell me what is this height? Okay, what is this height? This height. Hmm? Yes, you know, this is 4A, no? Why? This is 60, this is 60, this is 60. Then this is equilateral angle. If this is 4A, this is also 4A. Okay? Then what is this height? This is 60. 4A sine 60. Okay? 4A sine 60. Right, no? Right. We notice this as A. Then you can see this is also A. Then you can find this length, no? Okay? Right? Thereby, you can find this. A, and this is if you take as X, tan 60 is what? X over A. Okay? Then what do you get this height? This height comes as root 3A. Root 3A, right? Is it clear there? This is A. If you take this as X, tan 60, X over A, then X means what? A tan 60. Tan 60 is root 3. Right? Is equal to what? This side, this gives, I'll take this length as what, people? Right? L. L into what? Resolve this S force vertically. Vertical component of S force is this 2 root 3P. 2 root 3P. We need to find that L length. What do you get there? Root 3 P. Root 3 P. Root 3 P. We can cancel down. Right here we must put minus sign, no? Reason? Reason why? What is the reason? We take anti-clockwise movement, but that gives clockwise movement. Okay. Then here we get what? 4A minus 2A minus 2L. Here we get what? L minus A. All right. L minus A. L minus A means where? Yes, on the left of y-axis only, they should cut this way. Am I correct? L minus A means it should cut on the left of y-axis. Understand? Okay. Then ask him to find the equation of this line. People now tell me, what are the coordinates here? X coordinate minus A. Y coordinate 0. Right. Minus A 0. Am I correct? Yes or no? Yes. What is this S, the angle it makes with the horizontal? Alpha. Alpha given by what? We found alpha. Yeah. This tan alpha root 3 by 2. Tan alpha root 3 by 2. Okay. So this is alpha. Then what is the gradient of this line? Tan alpha. If you know the gradient M and this point x naught, y naught, if you know how to find the equation, y minus y naught equals gradient times x minus x naught. Gradient is what? Tan alpha. Now find the equation. Okay, equation. Right. Now you can write the equation. Therefore, the equation. Therefore, the equation you can write equation of S. Equation of S, y minus 0. Gradient means people root 3 by 2. X minus minus a. Yeah? X minus minus a. This gives us people the equation 2y equals root 3x plus root 3a. 5 marks. Okay. Right. Now, this marking scheme, of course, I got. There's a small mistake in the marking scheme. It's this equation is wrong. I don't know whether after that that has been changed in the new marking, but the marking I received, this answer is different from my answer. This is different from the marking answer, but this is correct. Reason uh, here, as I told you, the earlier result are here, right? The new force is here. They meet here. The new resultant should definitely pass through this point, this way. But they have found the equation of the S, taking moment around O, right? And putting the moment around O, right? So remember, the new resultant is not passed through the point this. That is a mistake in that marking I noticed. That answer is wrong. I say that definitely that answer should be wrong. Because I told you this, because whenever one day in the future, when you go through this marking and when you compare this answer with the marking, definitely you will put the blame on me. Because usually we highly believe the marking now, but that marking, the answer is wrong. Because they have assumed even after the new resultant R and this 2P, this new resultant passes through this point. Having that idea only they have taken now, but it's well obvious it is not passing through the point this, no. Right? Okay. So this is the correct answer. Right. Okay. Another one question we have, simple harmonic motion. That we'll discuss after break. Right. Take the next question, simple harmonic motion. I'll take really some time to discuss this one because in the simple harmonic motion, listen, we haven't done many sums yet. Okay. Yes, we'll read the question carefully. Question number 13 in the paper. Take question number 13 in the paper. Okay. It says, who did this question in the paper? You did got all the answers. Yes. Yes. It says, composite particle P of mass 2m is made by gluing together uh, two particles each of mass simple m. Okay. One end of a light elastic string of natural length simple A and modulus of elasticity 2 mg is attached to a fixed point O on a horizontal ceiling and the other end to the composite particle P. Right, okay. We'll draw the diagrams this way. This is 2023 SHM question. Right, so there are, once you really answer these questions, did you find more difficulty? No, not at all, no. So therefore, get by that the questions in the paper not difficult, but to do this type of questions in the paper, you must do some standard questions when you practice. Okay, right. This is a point O. Right. This is A. Okay. So particle P is hanging in equilibrium at the point A. At the point A. Right. Hanging in equilibrium, right? At the point A, like this. Hanging at the point A. I take this point A here to be here, right? This is the level A. Point A is this, huh? Then in equilibrium mean the total weight of P 2 mg, no? Right. 2 mg and tension suppose T1. Okay. I'll take the extension as L. Then at this equilibrium, you know what? 2 mg is equal to T1, no? Yes, you can first write T1 is equal to 2 mg because it is in equilibrium, no? How to write tension? How to write tension? Lambda, modulus of elasticity into extension divided by natural length, no? Natural length. Uh, Lambda 2 mg, I'm going to extend, assume extension as L, natural length given as A. S is equal to weight, 2 mg you can cancel. Now like this, we get L equals A. The extension at the equilibrium also A. That means this also A. This is A. This is also A. Right? At the equilibrium level, the extension is simple A. Right. Find the extension of the string at this position, equilibrium position, right? So then, there, for this you get 5 marks. Okay, write in this 5 marks given. Final answer, 5 marks given. Right. Okay, next one ask in this way. Show that if the particle P is pulled down a distance of A by 2 from A and released, right, and released, okay, the equation of motion of P is x double dot plus omega squared x equals 0 for x, right? This, where omega this, and AP x, right? So really, now what happens is this. From this level, here the equilibrium now, right? The particle P is taken from this level A downward a distance A by 2. Then it is released from here. Then what happens? It goes upwards direction. Okay. Then what happens? The particle should start the simple harmonic motion, no? Why? Once you release, particle moves up. Once it moves up, extension decreases. Then tension decreases. Then as the particle moves up, the force acting on the particle gradually decreases. That is the reason why the particle undergoes what? Simple harmonic motion. Variable force should act, no? Yes, all right. So we'll draw that diagram then. So then what is the diagram we suppose to draw? It is now pulled down from the point A, a distance A by 2. This way, a distance A by 2. Pull down up to here. This is A by 2 now. Right. From this position, it is released. Then it moves this way. Then we have draw a moment from this level A to the particle P. There is a third moment, the distance AP is x. That moment only we must now draw to develop what? That equation. That I am going to draw. Here O. This way. Right. Here we have weight 2 mg. From this level A, the distance is x. This particle is P. Distance is x. Then the expression is x double dot. Here tension, suppose T. X has been measured from the level A downward. Okay, right. Now what is asking there? Asking to obtain this. Okay. Now we can write F equals ma here. This is the moment T equals T. This moment T equals T. Put F equals ma. Downward 2 mg minus T 2 mx double dot. Right. Tension T how to write? Modulus of elasticity 2 mg. Okay. And extension. What is extension? Beyond the natural length, the rest all lengths going to be extension. What is that? Here A, here x, A plus x. Extension is A plus x. A plus x, natural length A equals 2mx double dot 2m, 2m, 2m we can cancel down. Okay, right. Then here we can take minus g over A out. When I take minus g upon A out, right? A plus x here we have. Here minus g over A when you take out. Here we get another minus A, no? Equals x double dot. Then this and this we can cancel down. We get x double dot minus g upon a x. This way we get this only. People, yes, ask him to take this way, right? We'll take omega as square root of g upon a. Then once I put here, okay, minus omega squared x double dot plus omega squared x equals 0. Right, no? Yes. And there you are given something like this for x less than or equal to a by 2, greater than or equal to minus a by 2. This also we must show there. Hmm? Okay, right? This is how we understand this thing. This x has been measured from the level A downward. From this level A to the downward only x has been measured. From the level A downward, the distance to this particle P is taken as what? Positive. Okay. From the level A, when the distance measured downward to the particle P, that is taken as positive x. So now suppose this way, now we know particle moves this way, no? And one moment it comes to A, right? Does it stop there? No. It furthermore move above the level of A. Once the particle moves above the level of A, this x, the distance of the particle, suppose the particle is somewhere here. When we measure the distance from A to the particle, when the particle is above the level of A, this x turns what? Opposite. Then x is what? Negative. Am I correct? X is negative. Now, since this particle is released from this position, a depth A by 2 below A, right? Tell me, above this level A, to what height this particle will move? Huh? To what height the particle will move? To what height the particle will move? Now, I repeat that again. From the level A is in equilibrium. We pull down the particle P A by 2 length from level A. Then we release. Once the particle start from here, what is the initial velocity? 0. And in the simple harmonic motion, what is the center? The level A, no? Why? How did we define the center? The point where no force acts on the particle, no? At the position of equilibrium, what is the force acting on the particle? No force. Why? T1 and 2mg equal opposite. No force, no resultant force. That is why we say the level A should be center. Am I correct? So, if this A is a center, at a depth A by 2, particle P start from 0 velocity. Then what is this level? This level should be what? The level corresponding to what? Amplitude. We know if the particle performs complete simple harmonic motion, the particle should move above the center another distance A by 2. But once the particle moves a distance simple A by 2 above the level of A, before that, if the string goes slack, it can't what? Complete the simple harmonic motion. But we are sure that until the particle reaches this level, string does not go slack. Once the particle comes to the midpoint here, still the string is slack. So therefore, in this case, the particle P can what? Can move on complete simple harmonic motion. Am I correct? Okay. So therefore, what is the maximum height the particle moves above A? Another A by 2. Reason? A by 2 is the amplitude. Right? On left and right, either sides of the center, particle perform the same what amplitude to complete the complete simple harmonic motion. So therefore, above this level A, what is the maximum height? A by 2. So once the particle comes above this A, we have to measure x this way. Then that moment x going to be what? Minus. So therefore, downward direction, what is the maximum length? A by 2. Above the A, also A by 2. Understand? Then what is the range of x? X should be positive value, maximum positive value what? A by 2. When it comes above the A, X negative minus A by 2. Understand? Okay. Then you can write that. Okay. This way we can take. This is valid for this into. Correct? No? X less than or equal to A by 2, greater than or equal to minus A by 2. Correct? No? Yes. This way we can take it. So here the marks come in this way. For this 5 marks given, for this another 5 marks given, and yes, for the last equation, 5 marks given here. Right. Okay, next one. Okay, fine. Now read the next part. Now the particle P is pulled down a distance of L from A. Right. From the level A, particle is taken downwards, distance L, and then released. Asking what? What is the maximum value of L for which the particle P will perform a complete simple harmonic motion? Can somebody answer this? Hmm? Right. From here, particle is taken downward L length, and released. Asking what is the maximum value of L so that particle performs complete simple harmonic motion. How to answer this? Anyhow, people, in order to make the complete simple harmonic motion, when the particle moves above A, string goes slack once the particle reaches here. At the point here or before that, particle should complete what? Its upper part of the SHM. If the particle has to move above this level, after that level up, no tension in the string. So therefore, above this A, on or before, at this point or before that, particle should complete the simple harmonic motion, upper part of A. Am I correct? You know, if the particle P is stretched, pull down L, it begins motion from 0 velocity. Then that L going to be what? Amplitude. Particle moves above the center level also, another distance equal to amplitude. We told before or at this point, the upward SHM, the particle should complete. Then maximum height, it should ensure to move at this. Then that L should be what? Simple A. The maximum value of L should be what? Simple A. Am I correct? Okay, no? Right? Okay. Simple A. Is it clear there? The logic? Once we take this particle P from the level of a distance L, and released. From that point, particles start with velocity 0. Okay? We know the distance from the center to the particle where particle has 0 velocity is the amplitude. Then amplitude is L. Then particle moves above the center level, the same amplitude. But it can go to that distance equal to amplitude as long as the string gives what? Variable tension. So the tension will be 0 after this point up. Up to this point, particle then can come to what? SHM. So therefore, maximum value of L should be what? This A. Understand? Okay. All right. Then write down like this. Particle performs SHM. Particle performs SHM from the center equal distance either side provided string taut. From the center A, maximum distance from the center A, maximum distance to the position of natural length, of the string is simple A. Therefore, maximum length of simple L is maximum length of simple L is simple L is simple A. Simple L is simple A. Right. I'll write down L equals A. For this, you get 10 marks. Read next part. Find the value of L for which the particle P will hit the point O with speed root AG. Right. P will hit the point O with the speed of root AG. Now, this is so. Here we have now. Okay. Right. Here A. Suppose this is that length L. This is L now. Taking this way L and particle is released. Then it comes to what? A. Then it should go above this level. You know. Otherwise it can't hit with O, no. Then you will very carefully understand. This time this arms of L should be what? Definitely more than simple A. Understand? Now once we release from here, coming to this point, particle performs simple harmonic motion, but not complete simple harmonic motion, incomplete one. If it completes simple harmonic motion, beyond this level up, it should not go, should come back. In this case, if the particle reaches to the point O, it should make incomplete simple harmonic motion. Up to this level, it comes under simple harmonic motion. Thereafter, it moves under gravity. Understand? Yes. Then we expect this L to be what? More than A. Is it clear? Yes. Now tell me, once you release this point, particle should hit with O with the given velocity, right? Root GL, GA. Here it should collide with the point O with velocity root GA. Can somebody tell me how to do this now? We can apply energy conservation theory. Okay. Once the particle is here, we can write the two energies it has. What is the first? Potential energy because of the position it lies. Other one is what? String is stretched. It's stored elastic potential energy. They are the two energies available. Once the particle moves this way and comes to here, potential energy is zero level. If I take here, it has no potential energy. Understand? Once the particle reaches here, string goes slack. No elastic potential energy. And it has only what? Kinetic energy. Understand? So therefore, once we equate that two energies here and here, you can find what this L. Is it clear? Right. Okay, then we'll write. Write on applying conservation of mechanical energy. Right? Yes. What are the formula for the elastic potential energy? Lambda x squared over 2a. A is the natural length. What is x? Extension squared, right? Once the particle is here, what is the potential energy? Here, this is A, this is A, here, L. No? Right. Elastic potential energy, we can write like that. Lambda given as 2 mg. Right. Natural length is A, then 2A. Extension squared. What is extension? This is A, this is L, A plus L, no? A plus L. It's perfect squared minus potential energy way 2 mg height A plus L 2A plus L equals here kinetic energy. What is that? Half mass 2m velocity perfect squared. Then it is GA. Hmm? Hmm? Right. Simplify this for L. So here marks given. Write in this energy 5 marks. Write in this 5 marks. And this is 5 marks. Here we can cancel down 2 mg. Right. Multiply by 2A. Then we get A plus L perfect squared. When you multiply this by 2A plus L. When you multiply this by 2A, 2 and 2 you can cancel down. A and A squared come in, no? For this we get 5 marks. Now simplify this. Here we have A squared plus 2A L plus L squared minus 4A squared minus 2A L equals A squared. This and this you can cancel down. Then L squared is 4A squared. L is 2A. No, as we expected, we get for L a value more than A. For this, another 5 marks come in. Another 5 marks come in. Right. Okay, no? Yeah. Read next part. When the particle P hits O at this speed, right. Now particle coming to here. With this speed, it hits with O. What is given there? One particle of mass simple m falls off. Particle P, composite object, no. One particle M falls off, removes, right? The ceiling is inelastic. What is meant by inelastic? Yes. Inelastic means what? You know, we learned in the impact of elastic body lesson, when we have this way fixed plane, when a particle is projected with velocity u on the smooth plane like this, it first make the collision with the fixed plane with velocity u. Okay. So we said there the rebounding velocity is eu. Is what? Coefficient of restitution. Once this way, people, if we drop a particle onto this ground, if it rebounds, that is because of what? The elastic nature only that rebounds. Inelastic mean, people, this E is 0. E is 0 means what? After the collision, no rebounding. No rebounding. That is the meaning of inelastic, E 0. The same thing happens. Particle P rises to this point O, then as it hits with O, simple M particle falls off. Other particle hit with what? The plane ceiling. Understand? But due to the collision, no rebounding velocity, 0. Then what happens? Will it stick there? No. The ceiling doesn't give backward direction velocity. Backward direction velocity ceiling gives 0. But the particle now simple M, not 2M. Simple M falls off, no. The other simple M particle with the string again begins to move under gravity from 0 velocity from where? Oh, downward. Understand? That's what really happens. Then what happens? Now the particle, simple M, earlier 2M, now simple M particle, that moves under gravity this way. After reaching this level A, the string comes to natural length. After that moment, what happens? The particle, simple limb alone, moves in a new simple harmonic motion. Why should we say new simple harmonic motion? Because earlier, particle had total mass 2m. With the total mass 2m, the characteristic equation is given by this. Right? There, when you take the characteristic equation, we applied F equals ma. That occasion, we had the weight of the particle as 2 mg. Now it is mg. Because of that, what happens? The new motion, for the new motion, the characteristic equation will change. That is why we must understand simple m particle alone, starting from 0 velocity from O, moves downward, it performs inward, new simple harmonic motion with new characteristic equation. Is it clear? இல்லையா ஓமா ஆமா நல்ல புள்ள right. Okay. Then we write like that. Write down. Ceiling is inelastic means the coefficient of restitution, simple E equals 0. Simple E equals 0. All right. Put that 5 marks. Put that 5 marks. Okay. Put 5 marks. Write down. Now, the particle simple limb, not 2m, particle simple limb. Now the particle simple limb begins to move downwards under gravity with initial velocity 0. With initial velocity 0. with initial velocity 0. Right. Now, what is the question asking there? Obtain the equation of motion for the new simple harmonic motion that the remaining particle performs after its motion under gravity. Yes. Now, we can draw very small diagram now. 2D diagram yang අපි අඳුමු ළමයා. Right. Here O particle is now simple M. Right. It moves under gravity what distance? Under gravity what distance? Simple A, natural length of the string. Thereafter that enters into SHM. Understand? Right. O A. Let us take the velocity here as what? V1. Right. How to find this V1? Apply equation of motion V squared equals U squared plus 2AS, and then start the new SHM. Yes. We'll find this P1. Shall I erase the early workings? Right. V squared equals U squared plus 2AS. We apply this way. V1 squared equals 0 plus 2GA. V1 equals square root of 2GA. This way, right? Okay. Right? Okay. For this 5 marks given now. Shall we find the time it takes to reach this position? We'll write time. Time. We'll write. Applying S equals ut plus a half at squared downward. Distance is A, initial velocity 0, half G. I'll take time is T1. Then T1 can then be subjected to A over G root. Right? Now for this also, 5 marks given. Right. Now I am going to draw equilibrium position, Lamai. I am going to draw the equilibrium position. So now really, we don't speak while this is moving, it comes to the equilibrium. No, what I'm talking is, once I gradually keeping our, on our palm this particle, when we gradually, slowly bring down it, one occasion, the palm, the hand will be moving, but object comes to rest. That diagram only I am going to draw. What importance of that level we need? That level is what? Center level. Equilibrium level is center level, no? To find out the center only, I do this one. At the equilibrium, write down, at the equilibrium. At the equilibrium. Shall we draw that equilibrium level? Draw the equilibrium level. Say here, equilibrium level. This is the equilibrium level. Mg, no, wait now. T dash. Let us take this as B, the extension. Right. At the equilibrium level, what can you say, people? T1. T1 we have used, no? We'll use T dash. T dash. T dash equals Mg. What is T dash? Modulus of elasticity to Mg. Extension I assumed as B. Natural length is A. It is equal to Mg. No? Mg. Mg you can cancel down. B equals A by 2. Now equilibrium level. A by 2. Yes, this is A by 2. Okay. Now can you explain the motion of the particle? as this level, the center level, understand? As this level as center level, it moves down until what? The position corresponding to amplitude. Huh? Position corresponding to amplitude. Huh? Right, okay. Yes, for this also marks given this way. For this 5 marks given, yes. For this 5 marks, this also 5 marks. Okay. Okay, now I am going to obtain the characteristic equation for the new motion. I am going to obtain the characteristic equation for the new motion. Right. This way. This is the equilibrium level. That means center level. From the center level, I allow the particle to move at the distance simple y. Earlier, since we have used x, though you use x again, never mind, but I take this as this time, this length as y. So I take particle is moving downward, pass in the center level, a distance y. Then you know the acceleration we mark as y double dot. Weight is mg. Tension I take as t double dash or whatever, right? Now apply here F equals ma and take what? For the new simple harmonic motion, the new characteristic equation. Okay, right. Take that. For the new simple harmonic motion, obtain the new characteristic equation. Applying F equals ma r downward, right? F equals ma downward, right? Apply that and give me the new equation. Right, then we get mg minus t double dash m y double dot mg minus t double dash lambda 2mg. Extension, when the particle is here, what is the extension? A by 2 plus y, no? Huh? Lambda x, extension A by 2 plus y. Lambda x over natural length, no? A equals my double dot. Simplify this. Yes. For this 5 marks given. For the equation, 5 marks given. Once you simplify this, people, you get y double dot is equal to minus 2g over a y. Okay. Then bring this to this side. You can write y double dot plus 2g over a y equals 0 for these 5 marks. Right. Right. Now, for the new motion, we need to find the amplitude. Can somebody suggest me how to find the amplitude? Center is this level. Okay. Not center is this level. Center is this level, right? Particle enters in simple harmonic motion from this level with velocity that v1. To that position, this is center level, no? The distance is a by 2. Can somebody tell me how to find the amplitude of the motion? We use x dot squared equals omega squared times a squared minus x squared. Understand? Yes. In this case, since we have used our y, what should be the equation now? Y dot squared, no? Y dot squared. Y dot squared equals omega squared times, right? Uh, I'll take a squared minus y squared like this, huh? We use this. People write in this, I'll take this capital A, yeah, because simply we have used there. For this also 5 marks given. Ah. Tell me what should be substitute for y dot? Once the particle passes this level, that means enters into simple harmonic motion, velocity v1, we calculated here. Its perfect square we put here. Then root will eliminate. What is omega squared? In the characteristic equation, this figure is omega squared. 2g over a. What is this a there? Amplitude. That only we need to find. A squared. Once the particle comes to this level, from the center level, what is the distance? A by 2. Then this y is what? A by 2. A by 2 perfect squared. A squared by 4. All right. Why just find capital A? Capital A comes as root 5 by 2a. Huh? Similar this, we get for this substitution 5 marks, and simplifying this, we get capital A equals root 5 by 2a for the this 5 marks. හරිද ළමයි? චූටි ගන්න තියෙන්නේ මේක ලොකුට තිබ්බට 150 marks. Don't give up this 150 marks. It's very easy question, no? Same thing again and again we have to do. Nice story, simple harmonic motion, no? Is at M. Right. As at M. Right. Now asking what? Next. තමයි කියන්නකෝ. දැන් මොකද්ද ස්ටෝරි එක? කියන්න. ළමයි කියන්නකෝ දැන්. දැන් මම තමයි කතා කරන්නේ හැම වෙලේම. Okay. Here amplitude root 5 a by 2. Right. This is center level, lamai. This is center level. From the center level, the particle moves another distance. Root 5 a by 2. Right. Right. This is the amplitude level. Root 5a by 2. No, this way. Right. Okay. This is the point particle enters into simple harmonic motion. Up to here, it moves under gravity. That time we found. Asking the total time what? From this O, once the particle comes to instantaneous rest, the time. That means once the particle comes to lowest position, the time. It has two motions, no? From here to here, under gravity motion. That time we found already there. Time t1 we calculated. Now we need to find the time under SHM from here to here. Tell me how to find the time under SHM. We draw a circle. Center should be where? Center of the circle should be where? Where? Center of the SHM. What is the radius? Amplitude. Understood? I will draw the circle. Small circle will draw. And then nani? Right. Right. Right? Now, when the particle moves from here to here and SHM, the corresponding circular motion, the circle I drew, the corresponding circular motion particle moves with what angular velocity? What angular velocity? Angular velocity is what? Square root of this, no? Omega is here, no? Okay? Can you remember that? Right. Then the particle which moves on the corresponding circular motion moves with the constant angular velocity 2g by a. This say 2g by a. Okay? When it comes to here, that particle turns on the circle, right? This angle. This angle it turns. Let us find this angle to be alpha. This is really a by 2. This radius is the amplitude root 5a by 2. Then tell me how to write cos alpha. Adjacent divided by hypotenuse. Right, cos alpha. Cos alpha. Adjacent side is a by 2. Hypotenuse is root 5a by 2. A by 2, a by 2 you can cancel 1. Alpha equals cos inverse 1 over root 5. Then what the SHM time? The angle is pi minus alpha. Angular velocity is this much. Therefore, what the time? SHM time? Yes, the angle divided by angular velocity. Understand? SHM time, T2. Therefore, T2. Right. Pi minus cos inverse 1 over root 5 divided by omega. Omega is that 2g over a root. Therefore, T2 a over 2g root pi minus cos inverse 1 over root 5. This is the SHM time. People, what is asking? What is asking? Total time, no? From O to the instantaneous rest, no? Total time. Total time means what? The time under gravity. Here we found T1 and this T2 we have to add. Total time. Therefore, write down total time. Total time. Yes, here the marks given. A, we okay. All right. This cos alpha, finding cos alpha, 5 marks given. And the time right in this 5 marks given. Right? And total time add. Total time T1 plus T2. Right? Substitute for T1, that's the time under gravity. T2, this time. When you put the answer for this, we get finally another 5 marks. Substitute for this 2 and put the answer 5 marks for me. This is a question. Is that difficult, the question? Is it difficult? Difficult. Oh. Not difficult, people. It's very simple thing. More works in it. But once you do this question 2-3 times, really, the same thing always to do to take the answer. So therefore, don't take seriously this. It's very simple one. Right. Revision number 2. So for that question, of course, it takes a long more time. So that question I discuss next week. It takes nearly 1 hour, more than 1 hour sometimes. That also a good question. So next week also you have to bring that paper. And today also we'll discuss MCQ questions, not MCQ, short questions, part A questions, revision based one, and third one I give you now. This is third paper. Second also induction. These questions, 2000, I think 23 part A questions. Okay, we'll do them. Right. Take question number 1. Using principle of mathematical induction, prove that 7 to the power n minus 1 is divisible by 6 for all n in Z plus should be there. R plus given as a mistake. Z plus, huh? Should be Z plus. I'll use the method. Complete this, right? 7 to the power n minus 1. N equals 1. What do you get? 6. What can you say? Divisible by 6. Result is true for n equals 1, no? All right. Result is true for n equals 1. Assume the result for n equals p. Hurry up. Right. Assume that result true for n equals p. What is the result we have to assume? When you put n equals p here, 7 to the power p minus 1 we get. We are going to assume this is divisible by 6. Then how to write this? 6k, right? What is k? K is a positive integer star, right? Proof for n equals p plus 1, right? N equals p plus 1 proof, right? We write 7 to the power p plus 1 minus 1. This we write 7 to the power p into 7 minus 1. I know. Then I write this, take this 7 out. We write 7 to the power p minus 1 inside the bracket. Okay. Really, once you remove the bracket, what do you get? 7 into 7 to the power p, this is coming. 7 into minus 1 is minus 7. But we must have only minus 1. Then we must add another 6 more, isn't it? Once we add 6 like this, what do you get? Minus 7 plus 6. This is coming. Correct, no? Yes. Then here, 7 times 7 to the power p minus 1 is 6k. Here we have 6. Take the 6 out. Once you take 6 out, what do you get? 7k plus 1. What can you say this now? K is an integer, therefore 7k plus 1 is integer. 6 into that means what? The left hand side is divisible by 6, no? Then rest ones you have to complete as homework. It's a very simple question. Past question 23 or 24 question this. Very first question, right? In part A, you find in your paper. Okay. Go to number 2. Go to number 2. Second one, also induction question. You are given this way, u1 equals to un plus 1, un plus 1 equals un plus 2n. N positive integer. Using the principle of mathematical induction, prove that un equals n squared minus n plus 2. Right. This is what we need to prove. We need to prove that this is true, no? We need to prove that this is true with the help of this information given us. නේද? මේක true කියලා පෙන්වන්න ඕන ළමයි මේ informations use කරලා. Understood? We prove the result for n equals 1. Where do we put n equals 1 then? In the expression we need to prove as true. This, no? In this. We take n equals 1 and substitute this. Okay? N equals 1. Put here n equals 1. This is the one we need to prove as true. Right. u1 come in 1 squared minus 1 plus 2. What is u1, people? 2. It is true? Yes, true, because u1 we are given as true. Result is true for n equals 1. Right. True for n equals 1. That's correct. assume the result for n equals p. Assumption. I write the short form. What is the assumption? UP. I am going to assume this is true for n equals p. UP, left hand side. P squared plus p plus 2. Take this as star. All right. Now we need to prove for what? N equals p plus 1. The same this become true. Right now. Right. When n equals p plus 1. When n equals p plus 1. When n equals p plus 1, this gives what? UP plus 1. Right? Substitute for np plus 1. This way plus 2. Right. Then we get UP plus 1. What is that? P squared. Here 2p minus p is p. Here 1 squared, then minus 1. We can cancel out this. We'll take this as a. What does this say? What does this say? When n equals p plus 1, this one gives us is this. Now if we can show the actual value of UP plus 1 is this itself, then this result is true for what? N equals p plus 1 as well. Am I correct? Am I correct? Then what I do is this. I am going to find this UP plus 1. This UP plus 1 we found directly putting n equals p plus 1. Here no. Now we are going to show really the actual UP plus 1 also this. Then only we can say that gives UP plus 1 correctly. Now I am going to find in the more reliable way what is UP plus 1. So this what I use is this now, people. This one. Using right. Using un plus 1 is equal to un plus 2n. Put n equals p. Put n equals p. UP plus 1 equals UP plus 2p. I proved, I said what? Whenever you prove the result for n equals p plus 1, somewhere in the proof we must use what? Assumption, UP. This UP now we replace by star because we have assumed UP correctly even by this. Okay. UP plus 1, UP, p squared minus p plus 2 plus 2p. This is by star. What do you get there? UP plus 1, p squared plus p plus 2. Right. So what is this result, people? If this UP is correct, then this should be the correct UP plus 1. Understand? If UP is correct, then this should be the UP plus 1. This should be the correct UP plus 1. But this also given what? Same expression for UP plus 1. Then what do you understand by this? If this gives the answer correctly for UP, then it gives what? UP plus 1 also correctly. Understand? Right. This is the one, actual one. By A, it says what? That gives correctly n equals p plus 1. Right. Then we can say by A, it says the result true for the result is true for n equals p plus 1. Right. No? Then that story you can write. That's what you can write. Right. Come to question number 3. Right. Question number 3. Show that limit x going to 1, 1 plus cos pi x divided by x minus 1 per f x squared equals 5 squared by 2. Number 3. Limit x going to 1. 1 plus cos pi x divided by x minus 1 squared. Limit x going to 1. This pi x angle, if I take as theta, we have cos theta. Write down cos theta in half angles. 1 minus 2 sine squared. Theta by 2, no? Sorry, 2 cos squared. We'll write that. 2 cos squared, theta by 2, pi x by 2 minus 1 divided by x minus 1 perfect square. These two we can cancel down. Limit x going to 1. Right. Here 2, here perfect squared. I must write inside bracket what? Cos pi x by 2. For a while, assume this pi x by 2 angle as theta. What do you have here? Cos theta, no? Assume this pi x by 2 angle as theta. Then we must write inside the bracket cos theta, no? But you can write cos theta as how? Sin 90 minus theta. Sin 90 minus theta is what? Cos theta. No? Sin 90 minus theta. Then I can write here sin 90 means pi by 2. What is theta really? This angle, no? Pi x by 2. Am I correct? Am I correct? Right. It's perfect square divided by x minus 1 perfect square. Right? Right. Now I do this. This 2 I can take out. Limit x going to 1. Right. See here, the thing I am going to do. This I can write sin, take pi by 2 out, but still inside the bracket. Pi by 2, 1 minus x. I can write like this. Okay. It's perfect square. I write that later. Perfect square. People, now here, this x minus 1 I can write as 1 minus x, no? Perfect square, no? X minus 1 perfect square. I am going to write square here outside. This then that square come in here as well as this. X minus 1 square is same as what? 1 minus x perfect square. Now I am going to put here pi by 2. I wrote pi by 2 inside this. This pi by 2 is what? Extra 1. To cancel this pi by 2, what should we write? Really, they are not just pi by 2. Since here we have square, here we have what? Pi squared by 4. To cancel down that, we'll write that we are here. Understand? Pi squared by 4. Okay? That pi squared by 4, you can take out here. Then 2 and 4 you can cancel down. We get pi squared by 2. Then you get the answer. How? Pi squared by 2 limit x going to 1. Right, what? Sin pi by 2 1 minus 6 divided by pi by 2 1 minus 6 perfect square. Right, now people, how do you take this now? Take this whole angle as theta. The same theta here we have. But as x going to 1, what happens? Here 1 minus 6 come into 0. Pi by 2 times 1 minus 6 assume as theta. Then here we have what? Sin theta by theta. But as x going to 1, here this bracket going to 0 means this theta going to 0. Then what is in hand? Sin theta by theta, theta going to 0. What is this? 1, no? What is this? 1. Right. Then what do you get? Pi squared divided by 2 into 1. What is the answer? Pi squared by 2. Hmm? Yeah. Hmm. Hmm. Mm-hmm. Right. And next one. Take now four graphs. Yes. Sketch the graphs of y equals half mod x plus 1. Ah. People, when we draw mod x graph, this is mod x graph. Then how to draw mod x plus 1? Hmm? When you add something here, graph coming to left by 1, no? Is it clear? Huh? Then how to draw this one? It comes to minus 1. Okay? Right? And but we need half of that. Still the point is this V-shaped graph come in, inclination will but decrease. Understand? Why? Gradient going to be half now. Is it clear? Huh? Why? Because mod graph is this gradient 1 here, 1 here. Then how to draw this graph? Take this to leftward. When we add 1, we know when we add something to this x, graph come in leftward. Then this vertex come in here. But when we have here half, what happens? Now half x, no. That means what? Here gradient 1, the gradient half. Then the branches come in closer to what? X-axis. Understand? Yes. Right. We'll do that now. Here minus 1. What is the equation of this part, people? Here define on the right of minus 1. Mod x plus 1 is x plus 1. We'll multiply by half. Half x plus half, no? Half x plus half. This sign? What? Hmm? Yes. X plus 1 mod will be on the left of minus 1. Minus 6 minus 1, no? 1, so multiply by half. Minus half. X minus half. Huh? Yes. Y equals minus half x minus half. Right. That we do. But next one. Next one, people. Or the 2x minus 1. Mod 2x minus 1. This 2 is positive, no? Then you can write this as how? This way also you can write. Hmm? Understand? First tell me how to draw mod x graph. This way. Right? Mod x graph I do. When this is multiplied by 2, what happens? Yes? This branch and this branch coming closer to y-axis because gradient increasing, no? Right. This way we have 2 mod x. Minus 1 means what? That graph we have to take downward by what? 1 unit. Am I correct? Yes. Right? Then it is at minus 1, 0 minus 1 place. Here. The graph coming like this. Right. Tell me the equation of this. What is the equation of this? On the right of 0, mod x is x, 2x minus 1. Left of 0, mod x is minus x, minus 2x minus 1. Other part. This is 2x minus 1. What is this? Y equals minus 2x minus 1. Correct, no? What is asking? Find all. Yes. Find this point A. Find this point B. Point A. Point A. Solve this 2. This 2, therefore. 2x minus 1 half x plus half. Bring here 3x by 2. 1 and half means 3 by 2. X equals 1. Here x equals 1. Point B. Point B. Here half x plus half. This line and this line, you have to simplify. Minus 2x minus 1. Here take 5x by 2. Bring this at minus 3 by 2. X is minus 3 by 5. This point is minus 3 by 5. Okay. Now what is asking next? Hence or otherwise. Don't go to otherwise part. Hence we'll take. Find all values of x satisfying this. Right. This way. We are given this, no? For mod x minus x plus 1 less than or equal to 2. Okay. I can write this 4 as 2 into 2. Second 2 we take inside the modulus because it is positive, we can take it inside. This way 2x minus mod x plus 1 less than or equal to 2. Divide this by 2. What do you get? Mod 2x minus half mod x plus 1 less than or equal to 1. Bring to this side. Mod 2x minus 1. Take this right hand side. Half mod x plus 1. This way. This is what we get. What is this really? Mod 2x minus 1 means this graph, V-shaped graph, this one. That should be less than or equal to other graph. This graph should be below the other graph. Other graph means this. In what interval of x this happens? This is smaller, less between A and B. No? Between A and B, this graph is below what? Other graph, no? In what solution? Between 1 and minus 5 by 3. Right. Then you can write that answer. X less than or equal to 1, greater than or equal to minus 3 by 5. That's how we take that answer. Take number 5. A positive, take 5. A positive, CB the curve given parametrically, x equals A times theta minus sine theta, y A times 1 minus cos theta. Ask to show dy by dx. All right. Here we can write dx over d theta. Tell me, we keep this A as the same. Now we go inside the bracket and what differentiate this. Theta, we differentiate with respect to theta, 1. Sin theta, we differentiate with respect to theta, cos theta. Am I correct? Yes. Here, dy by d theta. A is a constant, now go inside. 1 is a constant alone, 0. Cos theta root is what? Cos theta root is minus sin theta with this plus sin theta, A sin theta. Now use the chain rule. What is chain rule? Dy by dx. What? Dy by d theta multiplied by d theta over dx. Dy by d theta, A sin theta. D theta by dx means reciprocal of this. This comes to denominator 1 minus cos theta times A. Right. A and A you can cancel down. Sin theta, you can write how? 2 sin theta divided by 2 into cos theta divided by 2. This cos theta I can write how? 1 minus 2 sin squared theta by 2. This and this you can cancel down. Minus minus plus 2 we can cancel down. Sin theta by 2 we can cancel down with this. Sin theta by 2, one term. Cos theta by 2 divided by sin theta by 2 is cos by sin is cot theta by 2 that we get. And this is how we take dy over dx. Dy over dx is cot theta by 2. Cot theta by 2. Now ask to take second derivative. Find d2y over dx2 in terms of theta and deduce that c is concave downwards. Concave down. Concave down. Concave down, right? Right. So I am going to differentiate both sides with respect to x here like this. Okay. Then I must write it like this, isn't it? Cot theta by 2. Left hand side we get second derivative of y with respect to x. We write it like this. To right hand side we apply chain rule. For the place of dx we write d theta cot theta by 2 and d theta over dx like this I write. Am I correct if I write like this? The chain rule? We know this. People tell me, suppose we have here cot theta only. What is the derivative of cot theta with respect to theta? Minus cosec squared theta. Am I correct? Cot theta derivative is what? කොල්ලු පැටියෝ ආයසරයක් කරලා උත්සවය ගන්න ඕනේද පොඩි කාලේ ගත්තේ? පීයකුත් ගෙනත් තියෙන්නේ. What is the derivative of cot theta? Minus cosec squared theta. Right. Right. Minus cosec squared theta by 2. First we differentiate cot, then what? Derivative of theta by 2. Derivative of x by 2 is what with respect to x? Half. Theta by 2? Also half, right? D theta over dx. D theta over dx. D theta over dx means what, people? Take the reciprocal. 1 over 1 over a 1 minus cos theta, right? Right. Right. Now simplify this furthermore. Here 2 I can write 1 over 2a, no, minus 1 over 2a cosec squared theta by 2 Here, this cos theta we can write as 1 minus 2 sine squared theta by 2. This and this you can cancel down. How do you get then? Minus cos x squared theta by 2 minus minus plus 2 and 2a means 4a sine squared theta by 2. 4a sine squared theta by 2. People, we are given at the very beginning of the question a positive. A positive. If a is positive, 4a positive, this is perfect square, this is perfect square, this is also positive. Therefore, what can you say? Second derivative? Negative, no? Huh? Second derivative? Negative. Second derivative negative means what? Graph is concave. Concave down. Second derivative negative means concave down. Yes, correct, no? Therefore, concave down. Right. Number 6. 7 and 8, no? 2. Two more questions, no? Yes. Number 6 we'll take. Okay. Right, no? Second derivative positive means concave up. Second derivative negative means concave down. You can't remember these, go through notes, be ready. Number 6 now, take. L1 and L2 be the straight lines given by this, 2 by this. Find the equation of the straight line L3 that passes through the point of intersection of L1 and L2 and point minus 4, 4. All right, that one we can write like this, no? 6. Here, 2y minus x minus 2 equals 0. This one, 2x plus y minus 6 equals 0. Right, tell me any equation, any straight line passing through the intersection. Equation plus lambda times other equals 0. No? Right, L3. I take this as my L3. Yeah, given that passes through where? Minus 4, 4. L3 equation we can write like this. 2y minus x minus 2 plus lambda times 2x plus y minus 6 equals 0. But lambda, real number. Right. This passes through where? This passes through. This passes through minus 4, 4. Therefore, minus 4, 4 should satisfy this equation. Then here put 4, 8 plus 4 minus 2 lambda minus 8 plus 4 minus 6 equals 0. This gives us lambda 1. Lambda 1 coming. Put in lambda 1 here, you can find the equation of L3. Therefore, equation of L3. Right. Put lambda 1 here and simplify. You get this equation L3. L3 is x plus 3y minus 8 equals 0. Right. That is okay. Right. Correct, no? Now ask the next part. Also show that L3 is a bisector of an angle between L1 and L2. When you are given two straight lines, how to find the equations of angle bisectors? Yes, take this one equation, 2x plus y minus 6 and divide it by what? Square root of x coefficient squared plus y coefficient squared. Equals what? Plus or minus, take the other equation and write the same thing, right? 2y minus 6, 2y minus 6 minus 2, divide by what? Square root of 2 squared plus 1 squared. These two you can cancel down. Okay. When you take plus sign, you get one equation, minus sign, you get other equation. Take minus sign and simplify. What do you get? Take minus sign. 2x plus y minus 6 minus 2y plus 6 plus 2. Take this term to left hand side. 2x minus x is 6 plus 3y. Right? Minus 8. Right. When you take minus sign, we get 1 bisector. X plus 3y minus 8 equals 0. It is nothing but what? L3. Then this L3 is what? 1 bisector. 1 bisector. L3 is 1 bisector. Right. That's how we do number 6. Number 7. Circle question. Right. Take number 7. Find the equations of circles that touches the circle x squared plus y squared equals 4 externally, and also touch the lines y equals 0 and y equals 2. Y equals 0 means x-axis. Y equals 0 means x-axis. Y equals 2 means line parallel to x-axis cut in y-axis at 2. X squared plus y squared equals 4 means what? A circle where? Center? Center is where? X squared plus y squared. Yeah, center is 0, 0. Radius? 4. Hmm. Hmm. Center 0, 0. Radius 2. Oh. Right. Oh. Y. This is 6. Radius 2 means this is 0, 2 point. Then y equals 2 line is this. Y equals 2 line is this. Right? Right. X-axis means what? Y equals 0. Right. Now, in between these two lines, there is a circle that touches this externally. Huh? Yes. That should be like this, no? Another circle you can draw. How? This side, no? This way. Ask him to find the two equations. Huh? Right. Here, this is center. Here, 0, 0. When I join this and this. Right. This is 2. What should be the radius of this circle? What is this height? 2 units. Both this and this tangents. Therefore, diameter should be 2. Radius should be 1. Therefore, this is 1. This length from here to here 1, not the ratio, actual length. This is 1, this is 2. Okay? What is this height? Also radius 1. Then what is this length? Apply Pythagoras theorem. 2 plus 1 is 3. 3 squared minus 1 squared. 8. Its root. 2 root 2. Understand? Same geometry true for this, no? Huh? Same geometry true for this, no? Therefore, what should be this length? Minus 2 root 2. Then tell me what is the center of this? X coordinate 2 root 2, y coordinate 1. Center 2 root 2, y coordinate 1. What is the center of this? X coordinate minus 2 root 2, y coordinate 1. Am I correct? Yes. X coordinate minus 2 root 2, y coordinate 1. If you know center, if you know radius, can you find the equation? Yes. You can know. How? If we take a point here, x, y, the distance this we can write what? X minus 2 root 2 perfect square, y minus 1 perfect square is equal to what? 1 square. That's the equation of this circle. For this circle also, the same way you can take. Okay, no? Yes. Take that way. If you know the center and radius, you can find. Yes. Hurry. Simple things. Ask questions, we get simple questions like this. Number 8. Got number 8. Got number 8. Number 8. Solve for x. That means general solutions. Right. General solutions. Right. Last one. General solution. Sin x plus pi by 3 plus sin x plus pi by 4. Right. Is equal to cos pi by 24. Right. People, if you take this angle to be C, this as D, this is left hand side now, sin C plus sin D. Tell me sin C plus sin D formula. Sin C plus sin D formula. 2 sin, no? We start 2 sin. 2 sin. First add these two angles and divide by 2. X and x, 2x divided by 2, we get x. Pi by 3, pi by 4. 60 plus 45, 105. 105 divided by 2 means what? 52.5. 52.5 means what? 7 pi by 24. Am I correct? 52.5 means 7 pi by 24. Right. And what is the next one? Cos C minus D divided by 2. X and x we can cancel down. Pi by 3 means 60. 6 minus 45 is 15. 15 divided by 2 means what? 7.5. 7.5 means what? Pi by 24. Cos pi by 24. This is cos pi by 24. These two you can cancel down. You get 1 here. ආවාද? ගත්තද? අනි ගන්න. Sin Right. This is half, no? Divided by 2. So this half you can write how? Sine pi by 6. Sine equal to, you know how to write general solution. Yes. Sine x plus 7 pi by 24 equals sine pi by 6. Right. Sine equality, how to write general solution? Right, we can write it like this, no? X plus 7 pi by 24. What is general solution for sine equality? N pi plus minus 1 to the power n, right hand side angle. N pi plus minus 1 to the power n, right hand side angle pi by 6. Then subject this, taking this extra, this one pi by 2 to right hand side. Pi by 6 minus 7 pi by 24. All right, this is the answer. N is integer. Okay, this is how we complete that question. Right. Okay, then next week we need to discuss, bring paper-based revision 1, paper-based revision 2. Okay, then that simple harmonic motion of that question